Hey, very good morning, all my dear students. Just a second. Do let me know, my dear students. Your Baba HSP is audible and visible to all of you. Just a second. Let me see. Kids. Yes. Now, very happy good morning and welcome each and everyone to yours Unacademy NEET English channel. So after a very long time, Kashish, Omar, oh, Anish, Future, Medico, oh, fantastic. Welcome, Vanakkam. Very good morning. How is everyone? Yeah, definitely we will. After completing organic and physical, we will start inorganic chemistry also simultaneously and parallelly. We will go with each and everything. Very good. Anish Kumar, I can see Priyanka, Deshari, Ramakant. Oh, everyone is here, my dear students. So, we are going to start with this chapter, fabulous chapter. This holds a hell lot of weightage, my dear students. Let me tell you one very important thing that if you have very good knowledge of solution, that is molarity, normality, just moles, it's this chapter is very easy. Before I start this chapter, I'm good. JDSs after a very long period of time. Yeah, we are over here just after 1 week. It's how you're feeling. Future medicals excited. Everyone is excited. Sir, organic chemistry, when will you upload next video? It's after this chapter, solution chapter. After your solution chapter, we will start continuation of organic chemistry. My dear students, you are really excited. All the chapters after completing the basics, I will discuss each and everything. But dear students, see this question, number of questions I'm having over here. But kids, before I start this chapter, let me tell you one thing very properly, that this solution chapter is nothing if you have good knowledge of moles, because you know that moles are very tough because we are dealing with very fine particles. To calculate moles, it's really tough. So we are using weight, but weight should be given in this chapter and you are supposed to convert that weight into moles, because moles means everything. When we talk about solution chapter, when we talk about molarity, normality, it is the moles which holds a hell lot of weightage. Kashish, yes, yeah, I'm going to start. So, first of all, if anyone is new, let me tell you, this is your HSP Baba. Yes, I have been teaching for the last 23 plus years, produced number of ranks with the efforts of the students, parents, and me, my team. Degree, if you talk about MTech in 2004 and 99 MSc, MSc gold medalist, means topper, kids. So, if you're new to this channel, subscribe our channel, because for the best rank, this is the best channel in India, and you know that India is best in the whole universe, world. So, if you're new to this channel, subscribe our channel and like it. Hit the like buttons, everyone. I want to see that everyone, you have to hit the like buttons. Happy morning, Yashi is there, Deepti is there, Krishna is there. Wow. Now kids, let me start. So in this chapter, solution chapter, we are going to deal with basics, that is molarity, normality, and molality. For this chapter, for this particular chapter, I would like to say that this molality holds a hell lot of weightage. In this chapter, this small m, that is molality, that is going to play brilliant role. You can say this is the hero of this chapter, small m. And first, you know that molarity, normality, we know very well. Now, kids, after that, we will deal with colligative property, that is CP. So, everyone, you have to make one thing very proper. Sit with your copy and pen whenever it is required. Use it. Okay, kids, are you ready? And everyone, SRR group, Kittu, Rupa, Gopal, Vishnu, Abdul, Wahid, everyone, you have to respond over there. Make promise first. Everyone, make promise that you have to respond whatever the answer you are going to get. Because if you don't know the basics, if basics are not clear, we won't be able to get command on this chapter. We should have to have basics very clear, kids. Promise? Promise. Okay. Now, kids, I'm giving you this first question. Just try to understand. This is flask number 1. Let me tell you, this is flask number 1. This is flask number 2. This is flask number 3. And this is flask number 4. No hurry, kids. First accuracy and then speed. If you want to get the best rank, accuracy and speed, two important points are there. Speed is nothing. If your accuracy is good, automatically you are going to get speed, kids. So, let me make it first clear, the question clear, and let's see how much accuracy and how much speed you are going to get. Okay, how fast and how correct the answer you're going to get. First, let me explain. In the flask number 1, there is 1000 ml of water. We have added 98 gram H2SO4. This is pure. This was pure. This was the solvent. This is solute. On adding 98 gram of H2SO4 to this solution, we made H2SO4 solution. First point is clear. Once the solution has been prepared, we took out 50 ml of H2SO4 solution from the flask number 1 and we added to flask number 2. Now, kids, you must be thinking, sir, in the starting only you have started with the question. Kids, this is from mole concept. This is the basic. If you say, sir, we don't know molarity. If you say we don't know molarity, then I will first teach you molarity. Then I will give you a question. What do you say? Let me know in the chat section. You want to attempt this question right now? Or first, you would want to know the molarity from me. I'm thinking that molarity you know. You know molarity. Everyone, show me thumbs up if you are ready to accept this challenge, this question as a challenge. Okay, everyone want to attempt, and yes, see, then I will tell you the proper way to solve it, and I will let you know the milkman story also for this question, kids. If you are not able to solve this question, I will let you know the milkman story also. If kids, you are not able to solve this question, I will let you know the milkman story also. Milkman story, milkman story. What I will let you know? If you are unable to solve this question, I will let you know, kids, milkman story. What is that? How to do it without any formula. Milkman scientific approach. I will let you know milkman scientific approach. That is without using any formula. Without using any formula, how to solve the question. But yes, see, 2000 ml of water, 98 gram of H2SO4 has been dissolved. We have prepared the solution and then we have taken 50 ml of H2SO4 solution from flask number 1 and we added to flask number 2, which was already having 20 ml of pure water. In the starting, when we have not added anything, it was already having 20 ml of water and we added 50 ml of H2SO4. This will become little bit tough. Let me make it easy. Otherwise, it is going to be tough. In place of 20 ml water, let me have 50 ml of water. See kids, just to make it easy, I made it 50 ml of water. Now, once the solution has been prepared, I took 10 ml of H2SO4 solution from this flask number 2 and I added this 10 ml of H2SO4 solution to the flask number 3, which was already having 10 ml of water. This was already having 10 ml of water. Now, after mixing, I have taken 1 ml of H2SO4 solution from flask number 3 and I added to flask number 4 that was having 9 ml of water. Now, question is, what is the normality of this solution? You are supposed to find out normality of this fourth flask. If question is clear, do let me know. Once the question clear, if this question is clear to each and everyone, my dear students, first do let me know, then I will give you time to do it. If question is not clear, then also let me know so that I can explain the question once again. Okay, your time starts now. Kids, your time starts now. Let me see your answers. Who is going to give the correct answer and with what speed, kids? No answer. Till now, no answer. Okay, you take your own time. See kids, we have to get command. We have to make it so super easy so that we can deal with this chapter. We can understand this chapter clearly, kids. You are taking too much time, kids. You are taking too much time. This much time you won't be getting in your examination. No answer. Sangeeta Govind Swami, this flask number 1 was having 1000 ml of water, that is 1 liter water, and containing 98 gram of H2SO4 solution. From this solution, we have taken 50 ml of H2SO4 solution and added to 50 ml of water. 50, 100 ml of solution. From this 100 ml of solution, we have taken 10 ml of H2SO4 solution and added to 10 ml of water. Then 1 ml of H2SO4 solution we have taken and added to 9 ml of water. You are supposed to find out the normality of fourth flask. Flask number 4, normality you are supposed to find out. Its density is not given. Density is not given. That is the question. No one. Kids, your time is up. This much time you're not going to get. How many of you want to solve it from my side? Because till now I haven't received the answer. Kids, this solution chapter is nothing. It is just the extension of your mole concept. Molarity, just moles, nothing else. Kids, how many of you want so that I can explain? Fast, kids. I haven't got answer from anyone. So write down me, I will solve it. Now kids, should I, okay, let me tell you the simplest one. To solve this question, I'm not going to solve this question. I will make you able so that you can solve it easily, okay? You are the only one who is going to solve this question. I will make you that much intelligent so that you can solve it in within fraction of seconds, in 1 second. How many of you want 1.81 normality? Wrong. Tulika, your answer is wrong. Yashi, your answer is wrong. Everyone. Now, kids, how many of you want I should make you that much intelligent so that you can solve this question within fraction of second, 1 second? Yes, kids. Now see, try to understand. Let me tell you, 1 by 9, wrong. Kashish, your answer is also wrong. See, kids, if I take this flask and suppose I am having 1000 ml of water, 1000 ml of water, and I have added 98 gram of H2SO4, 98 gram H2SO4. So kids, first of all, do let me know, do you remember the formula of molarity? Molarity is defined as number of moles of solute dissolved per 1 liter of solution. What is molarity? Number of moles of solute dissolved per volume of solution in liters. Volume in liters. Am I right, kids? Am I right? So we can write down molarity is equal to number of moles upon volume of solution in liters. Now kids, what is the formula for number of moles? Molarity is equal to number of moles weight of solute in grams upon gram molecular mass into volume in liters. WB. Let me take A as solvent, A to be solvent and B to be solute. I have taken A as solvent and B as solute. So this is the formula, kids. So 98 gram, find out its not molarity, kids. What should be its molarity? Molarity will be weight of solute, that is 98 gram. Molecular mass of H2SO4 is 98. Volume 1 liter. 1 liter. So how much is the molarity coming out, kids? How much is the molarity coming out? Molarity is 1. Everyone is correct. Fantastic. Molarity is 1. How much should be its normality? Normality, we know that normality is equal to molarity into valence factor. So H2SO4 in water, valence factor is 2. So 1 into 2. So normality is 2. Am I right, kids? Normality 2. This much is clear? Clear. Now see, milkman story. Milkman story says, if you take this flask, take this flask, and let us suppose this flask is having 100 ml of water, 100 ml of water, pure water, and here you are having 1000 ml of H2SO4 solution, whose normality is 2. Okay, now what you did, you have taken 100 ml of H2SO4 solution and added to 100 ml of water. Added to 100 ml of water, kids. Now let us find out the normality of the solution. Kids, first of all, let's see milkman story. Don't think about normality. What happens, kids? Whenever we are drinking Pepsi, milk, we think about concentration, how much tasty it is. Kids, first of all, do let me know, if you are having one glass, if you are provided with Pepsi, this is Pepsi, Cola Pepsi, half glass Pepsi, half glass Pepsi, and somebody has added water to this Pepsi, water, and now it has become full glass Pepsi by adding water, kids. 1 glass Pepsi. Will you enjoy it? Will you enjoy this Pepsi? Do let me know, are you going to enjoy this Pepsi? If this Pepsi has become, no, because it has become diluted. It has become diluted. So the first one is more tasty. Taste, normality, concentration is equivalent to taste. It's taste. The first one was more tasty or the second one is more tasty? Definitely this was more tasty, and you added half glass of water. That means you have done dilution, concentration decreased. Here the concentration got decreased and dilution got increased. Am I right, kids? Am I making sense? Am I making sense, kids? Are you able to get it? Now see, kids. Let us suppose this is not H2SO4 solution. Just suppose this is milk. Suppose this is milk. This is milk and its taste is 2. Taste is 2. 2 point. In place of H2SO4 solution, you just think it is milk. A milkman is having milk. Milkman's cow or buffalo, that animal has given milk. The taste of milk was 2 point and the volume was 1 liter. The milkman is having 1 liter milk, and the taste of that milk is 2 point. Can you believe this, kids? Then I will tell you in the scientific way also. But first of all, listen to me, the milkman story. Now see, kids, what milkman has done, he has gone to Champa. Champa was his customer, and he is supposed to give 200 ml of milk to Champa. 200 ml milk to Champa, but he was not having that much of milk. What he has done, 100 ml of milk having taste of, without water, having taste of 2 normal, he has given to Champa and he added water to it. Whatever the amount of milk was, same amount he added milk and he made it 200 ml. So kids, what Champa is getting the milk, is that much tasty or less tasty? Do let me know. Yeah, Sanjeev Kumar, it is important for JEE, NEET, all. Kids, do let me know, this Champa is going to get same tasty milk or less tasty milk? Kids, do let me know. Champa is going to get same taste or less taste? Less. How much less? How much less? Right now, without adding water, the taste was 2, and the same water and the same milk, the taste will become half. Taste will become half, less than 2, half, exactly half. See, whatever the amount of milk, same amount of water, so the taste will become half. Its normality will become 1, because 2 divided by 2 will become 1. Now kids, how many of you want I should solve it with the formula? See, I'm going to solve the same question with the formula. Now see, kids, the same question I'm going to solve with the formula. See, kids, this was the solution, H2SO4 solution. Its normality was 2. It was having 100 ml of water. From this solution we have taken 100 ml of H2SO4 solution. Now see kids, we know that dilution formula. There is one dilution formula. Dilution formula. What is that? What is dilution formula, kids? N1 V1 is equal to N2 V2. I know that you know very well. N1 V1 is equal to N2 V2. You know, kids? Do you know? Now, the N1 it's 2. N1 is 2. Volume is 100. N2 we don't know what volume will be. 100 plus 100. How much? 100 plus 100. How much, kids? 200. 200. Just solve out what should be the normality. Normality N2 will be 2 into 100 divided by 200. How much it will come out, kids? How much it will come out? That is 1. See kids, who has got answer earlier with more speed? The milkman or the students? These are the students. They are learning chemistry. These are the students. They have got answer, same answer after this much of time. The milkman has got the answer within fraction of second. Who is more intelligent? Who is more intelligent? The milkman, who is illiterate, who has not done any coaching, or you students are more intelligent? Kids, do let me know who is being more intelligent. Who is being more intelligent? The milkman who doesn't know even the ABCD of chemistry, or you students, those who are spending that much of time? Now see kids, see, this is your HSP Baba. This is your HSP Baba. This HSP Baba is going to give you questions. See kids, one more question. See to it. See. Everyone see to it. See everyone. This is one flask. This is second flask. This is third flask. And if I say in the first flask, this is 1 liter, 1 liter H2SO4 solution, H2SO4 solution, its molarity is 1. It is having 10 ml water, pure water, and this is having 5 ml pure water. Okay, these are the 3 flasks. What I have done, I took 10 ml of H2SO4 solution, 10 ml H2SO4 solution, and added to this flask. 10 ml, 10 ml, I make 20 ml, and from this 20 ml, I've taken out 5 ml of H2SO4 solution, and I added to this flask, already having 5 ml of water. Now the question is, what is the normality of this solution? Normality. Now, either way you do, just like scientist or like milkman, whatever, it's your choice. I would like to see the answer. Let's see how fast and how accurate answer you are going to give. I want to see kids. 1. Sangeeta Govind Swami has given answer 1 within fraction of seconds. Let me check it out. What other students they are going to get? Everyone. Kashish 1, 1, Pinky 1, everyone is getting 1. Now let me solve it. Let me solve it first like milkman. First like milkman. Scientific milkman. Scientific milkman. He is always going to add water to the milk. Its normality is how many replaceable H in H2SO4? How many replaceable H? Basicity of H2SO4, that is known as N factor, that is known as valence factor, is being 2. So normality is equal to 1 into 2, that is 2. Now same amount of water you have added, the taste will become half. So after mixing, normality will become 1. Oh, it has become 1, and once again its normality will become half of 1 by 2. Half of 1 by 2. What is the answer, kids? What is the answer? It's not 1. because it was having normality 2, its normality is 1, and once again you are adding same amount of water, 1 by 2, it will become 0.5. It's not 1. Now, let me solve with the scientific formula. See, kids. Let me solve with the scientific formula. See, everyone. N1 V1 is equal to N2 V2. How much is N1? 2, 10, N2 we don't know. 10 plus 10, 20. So N2 will be 20 by 20, how much? 1. So its normality is 1 till now because no water we have added, but we have added 5 ml of water. Now N3 V3 will be equal to N4 V4. What is N3? 1. Volume 5. N4 we don't know, but 5 ml plus 5 ml of water. 5 plus 5, 10. So N4 will be equal to 5 upon 10. How much gets? 0.5 or 1 by 2. See, in both ways I have solved the question. Kids, are you able to understand? I have solved like scientists the dilution formula, which always you were applying the dilution formula, and I have solved the question by applying milkman story. Which one is better? Which one is easy? Which one is making you visualize things? The milkman story is able to visualize you, or the dilution formula is able to visualize you? Kids, do let me know. Which theory is making you more broad? Okay, JDSS is saying give another question. See, kids, let's see to original question. Let's come to our original question. This was original question, kids. See, now this flask you are supposed to tell me what is the normality. This is the original question, kids. Joseph, Rani, I will let you know how to calculate normality. Don't worry, I will let you know. Joseph, I will let you know. Now everyone, I want to see the answer. Let's see, kids. And everyone hit the like buttons if you're liking my approach. If you are enjoying my approach, if you're liking my approach, hit the like button. Don't forget to smash the like button. This is your attendance. Yes, marked it right now. 0.25, 0.05. Anish is getting 0.05. Bharatnan is getting 0.25. 1 by 4. Bedha Janani is getting 1 by 4. Let me check it out whose answer is going to be correct. Because 2 students, they are getting 1 by 4. 1 student is getting 0.05. Let me check it out who is going to get the 0.125. Oh my God. Satvik is getting 0.125. Everyone is getting different answer. Yashi is getting 0.02. Now, how many of you want that I should solve this question for you people? With which approach? With milkman scientific story or with N1 V1 N2 V2? Omar Adan is getting 1 by 18. Kids, it's the magic going on. Call each and everyone, one student, everyone call one student of, they can be your friend, relative or whatever. The magic of chemistry is going on, kids. Milkman, okay, see. Everyone is, okay. Joseph is saying N1 V1 N2 V2 milkman. Both the way I will solve it. See, kids. 98,000. How much is the normality of solution? Everyone do let me know. What is the normality of this solution? Everyone, please do let me know what is the normality of this solution. Normality of this solution. Everyone do let me know, kids. How much is the normality of this solution? 2. So everyone, you have got normality is 2. Till now, I have not added water. Till now, see, kids, it's a pure. Till now, it is pure. Its normality is also 2. Because till now, water has not been added. But this 50 ml, as soon as this 50 ml of H2SO4 solution is going to collide with 50 ml of water, water will make it diluted. Normality will become more or less. Normality will become more or less. Do let me know. Less, it will become half. Half. Half of 2 is how much? Half of 2 is how much, kids? 2 into 1 by 2, that is 1. 1. This is milkman. Now, till now we have taken solution after mixing. Till now its normality is 1 only, 1. But as soon as I am going to add this H2SO4 solution to same amount of water, once again it will become half. So half of 1 is how much? Half of 1 is 1 by 2. Till now milkman story is clear. Till now milkman story is clear. Now see, till now normality is 1 by 2. 1 by 2. But only 1 ml of H2SO4 solution and 9 ml of water. 9 plus 1, how much? 10. The milkman has just taken 1 ml of water and added water, and it has become 10 ml. How many times dilution increase, kids? How many times dilution increase? 10 times dilution increase. So 10 times normality will decrease, kids. Dilution increased 10 times. So the normality will decrease 10 times. 10 times normality will decrease. Now normality will be, yes, how much? How much? How much? This was 0.5. 0.5 divided by, or you can see 1 by 2 divided by 10, or you can say kids 0.5 divided by 10. How much is the answer? How much is the answer? 0.05, kids. 0.05. 0.05 is the answer. How many of you are able to understand, kids? How many of you are able to understand? Whatever the amount of dilution you are increasing, same ratio concentration will decrease, and that is known as concentration is inversely proportional to dilution. Hey kids, how many of you are liking it, kids? First of all, do let me know. Now I am going to tell you with the help of N1 V1 N2 V2. See the same question with the help of N1 V1 N2 V2. Now see, N1 V1 is equal to N2 V2. N1 is 2, V1 is 50, N2 we don't know. 50 plus 50, 100. So what is the value of C? N2? N2 is equal to 100 upon 100. That is coming out 1. Got it? Everyone got it? Balamas, thank you. AK Balamas, God of chemistry, kids. I will let you know. I was telling you organic. How is my physical? First of all, everyone do let me know. How is my physical? Now, here N3 V3 is equal to N4 V4. N4 V4. Now, just see to it. N3 is 1. Volume is 10. N4 we don't know. 10 plus 10, 20. So N4 is equal to 10 by 20. How much gets? 10 by 20 is how much? 1 by 2. Now see the last one. The last one. Everyone see to it. N5 V5 is equal to N6 V6. N is 1 by 2. 1 by 2, where to write it? Let me take fresh page. 1 by 2, 1. 1 by 2, 1 by 2 into 1, and N6 we don't know, but it is 10. So how much gets N6 will be how much? 1 by 2 is 0.5 divided by 10. This will come out 0.05. How many of you are able to understand, kids? Amazing, everyone. Now, kids, should I give you one more question? Kids, if you know this thing, see, kids, how many chapters you can solve easily? if your concentration is simple, if your molarity is having well command, if you know molarity, then solution chapter you can do, chemical ionic equilibrium you can do properly, you can do electrochemistry properly, kids. Electrochemistry you can do very well. Surface chemistry you can do very well. Surface chemistry, all these chapters you can do within fraction of second, just having the knowledge of molarity only. If you have good command on molarity, redox, yes. Now, should I give you one more question? Are you ready for another question? Everyone, do let me know, kids. Okay, see, how many of you want another question, kids? Yes, do let me know how many of you want another question. See, whatever the approach you are going to apply, you apply, but solve this question. 1, 2, 3. This is having 44.6 liters NaOH solution. NaOH solution. Its molarity is 4 molarity. Now it is having 20 ml of H2O, and this is having 10 ml of H2O. Now what we did, we have taken from this, from 44.6 liters, we have just taken 20 ml of NaOH solution, and after mixing 20 has become 40. After mixing, what we did, we have taken 10 ml of NaOH solution and added to this 10 ml of water. Now the question is kids, what is the normality of this solution? Normality of this solution. Let me find out how much time you are going to take, kids. How much time? No problem, Buddha Surya. Welcome, welcome. Let me check it out how much time you are going to take, kids. Oh, fantastic. Now everyone has become educated. Kids, see, it's 4. It will become half. Half of 4 is, normality will become 4 into 1 by 2, because 20 ml, dilution increased. Dilution increased twice. So the concentration decreased twice. Concentration decreased twice. So it has become 2. Now you have taken 10 and 10. Once again dilution increased twice. So concentration decreased twice. So normality will be 2 into 1 by 2. This is 1. Kids, have you done this question with the milkman style, or you have applied N1, V1, N2, V2? Kids, do let me know. You have done this question by applying milkman formula, milkman, the milkman, scientist milkman, or you have done this question by applying N1, V1 is equal to N2, V2. Everyone. Now, kids, now let me tell you what is the balance factor, what is normality, molarity, and then we will move ahead. Kids, see, this is the question. Find out the answer. Options are given over there. Let me check it out. See how much homework I have done for you. Number of questions today I will give you based on colligative properties. Everyone, kids, fast. What's the question's answer? Fast, fast, quick. Kids, quick. I want to see answer. Without taking too much time, find out the answer. Now see, kids, how to do it. NaOH, 40 ml of solution. So either you can apply formula molarity, normality, because NaOH, how many OH it is going to give? It will give just one OH. So whatever the OH it is going to give, that is its N factor. N factor is equal to 1 only. You can call it N factor. You can call it valence factor, whatever you want to say. Oh yes, C is the correct answer. And now those who are not able to find it out, let me tell you, weight of solute in gram, gram molecular mass, volume in ml, and if you are writing volume in ml, you have to divide it by 1000. Now this 1000 will go up. Once this 1000 is going up, the formula for molarity will be weight of solute in grams upon gram molecular mass, volume in ml into 1000. Just put in the formula. If you put the things in the formula, what you are going to get C, you will get 0.4 upon 40. 40 is its what? Its molecular weight. Na is 23. It should be given in your exam. Oxygen is 16 and H is 1. How much kids? Find out. 67304 40, and 40 is given over here multiplied by 1000. Now the calculation is tough. Kids, how to do the calculation? See, this 1 point will eliminate out, these 20 will eliminate out. Now 4 will eliminate out. 1 by 4 is how much? 1 by 4 is how much? 0.25. This was the oral question. This was the oral question, kids. Everyone, are you able to get it? This was just the oral question. Now kids, let me tell you molality, because calculate the molality. First, let me tell you what is molality. What is molality? Let me tell you. Then only you can solve this question, kids. Molality means, this is the hero of this chapter, molality. Just see, molality. We are talking about L. L for laddu. L is there, small m. It is different from molarity. That is capital M, riti, ritik, R. Here L, L for laddu. Now see kids, molality is defined as, number of moles of solute, number of moles of solute dissolved per kg, 1 kg of solvent, 1 kg of solvent. How it is different from molarity? See, focus over here. Kg, the weight, and the solvent is there. In molarity, there is solution. Molarity, capital M, is defined as number of moles of solute dissolved per volume of solution in liters. There is volume of solution. Here is weight of solvent. Kids. So see, what should be the formula? Molality is defined as moles of solute dissolved per 1 kg of solvent WA. Now weight of solute in gram upon molecular weight of solute, and this 1 kg, and if it is given in grams, how the formula will change out, kids? See, the formula will become WB in grams. Remember that, in grams, upon gram molecular mass, weight of solvent in grams into 1000. This is ready-made formula, kids. Everyone, this is the ready-made formula for small m. Always apply this formula. This formula will give you the correct answer. Clear, kids? Is it clear? Is it clear, kids? The formula of small m is clear to all of you. Weight of solute in grams, molecular weight of solute, weight of solvent in gram. A means solvent, B means solute. Now, this is your question. If formula is clear to all of you, now let me give you Na is 23 and Cl is 35.5. These are the atomic weight. This should be given in your examination. Find out the answer. Thank you, Joseph. JDSS, I want to see answer, kids. Everyone, do let me know what's the answer. D. Omar's answer is being D. Take care. Akanksha is getting C. Vedha Janani is also getting C. Dipanda is getting C. Everyone is now getting C. And I hope that C is going to be the correct answer. C is going to be the correct answer. C, why? If I put these things in the formula, what is the formula, kids? What is the formula? Formula was small m is equal to weight of solute in grams upon gram molecular mass into 1000 weight of solvent in grams. Remember that these things. So let me put the values. Calculate the molarity of solution obtained by dissolving this much of gram. 11.7 gram. Molecular weight will come out. How much? 0.5, 538 and 58.5 divided by 58.5. Now, this much is given 500. So, 500 into 1000. Now, it is totally maths. Oh my God, how to solve it? The calculation. Remember how to do the calculation smartly. See, kids, the options are very close. So, you have to do it very smartly. Now, I can do one thing. 11.7, can I remove this point and this? Okay. Now, remove these 2 points. Okay. Now, is there any relationship in between 58.5 and 117, kids? It is the double of its. So, can I write in place of this 2 divided by 2, how much is left? Kids, anything is left? 5. 2 by 5 is how much? 2 by 5 is how much, kids? 2 by 5 is how much? 5 4 ja 20, so 0.4. Everyone clear? The calculation is clear to all of you, kids. Have you got it? At least show me the thumbs up, kids. What are you doing? If you are able to understand, it's your duty, moral duty, to show me the thumbs up, kids. Your Baba is doing that much of efforts and you're not able to show me the thumbs up, kids. And hit the like buttons if you're new, kids. This is not the way. This is your Baba only. Baba is doing that much of efforts. Now, kids. Okay. Now, let me tell you one thing. Have you ever eaten kheer, what to say, the rice cooked in milk, what do you call it? Rice cooked. Okay, coffee. Let's see coffee. What do you enjoy more? Hot coffee or cold coffee? Hot coffee or cold coffee? What you like more? Hot coffee or cold coffee? Kids, do let me know. What you enjoy more? Hot coffee or cold coffee? Hot coffee. Okay. Earlier it was tea only. Earlier it was tea. Nowadays cold tea is also available. Okay. Everyone is liking Kids, everyone is saying that they like. Everyone is saying they are liking. Somebody is writing liking cold coffee. Okay, kids. Which one is more sweet? Suppose your mother made coffee and the temperature of that coffee was, let us suppose, 40 degrees Celsius, and its taste, better to say its concentration or the sweetness, its sweetness was having 4 point, must have added sugar to it, sweetness was 4. So which coffee will be more sweeter in taste? Hot coffee will be more sweeter or cold coffee will be more sweeter? This is my question. My question is, kids, which coffee is more sweeter? Which coffee will be more sweeter? Kids, do let me know. Cold coffee, yeah. This is your experience or you have any logic? Definitely the answer is cold coffee. Cold coffee is the answer. Now kids, do let me know, is this, you told me the answer with your experience or you have applied science? Kids, do let me know, this is telling you your experience or you have applied science? Kids, do let me know. Experience. Very good, kids. You are true students. You are brilliant students. Now, how many of you want the science behind it? This you have told me with your experience. This you have told me the answer with your experience. Now, how many of you, kids, how many of you want to know the science behind it? Kids, do let me know. How many of you want to know the science behind it? See, the science of it is that if I say molarity is equal to weight of solute upon molecular mass, volume of solution in liters, volume. Now kids, is there any relationship temperature of volume? Do you find any relationship of temperature and volume? Is there any relation, kids, in between temperature and volume? If you are going to increase the temperature, volume will also increase. And if volume is getting increased, the molarity will decrease. Am I right, kids? If you are going to increase the temperature, volume will also increase, and volume is increasing, then concentration will decrease. Now kids, if you decrease temperature, volume will decrease, the molarity will increase. So kids, are you able to get it? That's why in older days everyone was having hot tea, hot coffee, everything they were eating hot. But nowadays everyone is switching towards cold coffee, cold tea, cold ice cream, cold drink, and that's why cold drink is famous. This is the way only why cold drink has become famous. This is only the way that everyone wants to have chilled cold drink, because this is the reason. Now how the examiner will ask the question. Examiner will ask the question like this. Examiner will ask like this: which is not dependent on temperature, which is not dependent on temperature, kids. Option A, molarity. Option B, normality. Option C, molality. Option D, all of these. All of these. Kids, do let me know what should be your answer. This is capital M, this is capital N, this is small m. Could you please let me know what's the answer? C. That's really fantastic, kids. And that's why this small m is the hero of this chapter. Now I'm going to start this chapter because whatever I've told you right now, this was just the basics you must have studied in your class 11th. Now one more question of class 11th I'm going to tell you, that is from mole concept, and then I will enter towards the colligative property. Kids, are you ready for that question? Is everyone ready? See, the question is if I am provided with this solution, I'm provided with this solution, kids. Here is the solution, and it's written over here. It is marked as 2 normal H2SO4, and the volume is marked as 1000 milliliters. 1000 milliliters. Now, this is distributor, the one who has brought this. This is the distributor. Now, this is the main distributor of acid. Main distributor of acid. Now, there is Ramu and Shamu. These are small acid sellers, Ramu and Shamu. This main distributor's name was Champa. Champa was the main distributor's name. This Champa has given 20 ml H2SO4 to Ramu, 20 ml H2SO4 to Ramu, this solution, and this Champa has given 30 ml H2SO4 solution to Shamu. Okay, what Ramu has done, Ramu added 20 ml of water to it, 20 ml H2O to this solution, 20 ml H2O to this, and has given this 40 ml H2SO4 solution to Alia. This solution he has given to Alia. Now kids, could you please let me know what is the normality of Alia's H2SO4? Let me tell you, this Champa was the main distributor. She was having H2SO4 of 2 normality, 1000 ml. Champa has given 20 ml H2SO4 solution to Ramu. Ramu added 20 ml of water to that solution. Now it has become 40 ml, and Ramu has given this H2SO4 40 ml to Alia. Now what is the normality of Alia's solution? Question is clear? Is question clear, kids? First of all, do let me know question is clear to all of you. Is the question clear to all of you, kids? Okay. Now let me know what's the answer. Everyone, do let me know what's the answer. I'm waiting for your answer, kids. Let me see to it. What answer you are going to get, kids? Joseph is saying, please explain once again. Everyone is giving the answer. This is solution of 2 normality. Champa is having this H2SO4. Champa has given 20 ml H2SO4 to Ramu. Ramu added 20 ml of water. It has become 40 ml. And this has Ramu has given to Alia. Now, what is the normality of Alia's solution? 1. Let me check it out. 1 is correct or not. Let me check it out, kids. 1 is the correct answer or not. See, kids, everyone. Normality is 2. Till now, no water has been added. Nothing has been added. No water, no H2O added. Now, kids, help me. What is the normality of this solution? Ramu, whatever the Ramu has got, what is the normality of that? Everyone. Whatever the Ramu is having, what is the normality of this solution? The Ramu is having, kids. 2. Because it is pure, its normality is 2. Now, what Ramu did, Ramu added 20 ml, that the dilution increased twice. Dilution increased twice, 2 times. So, the concentration will decrease 2 times. So, its normality will become half of 2, 2 into 1 by 2, that is 1. So, the answer is 1. Kids, now your life has become easy because of milkman story, or it has become tough, kids. Everyone, Krishna, Joseph, Akanksha, JDSS, everyone, do let me know. Now your knowledge increased or not? First of all, everyone, do let me know. Share it wherever you can share it. Call everyone, kids. Now, see, kids, I'm coming towards colligative properties of dilute solutions. This is our chapter. Colligative properties of dilute solutions, CP. This is the trick. Redo, HSP Baba's trick, HSPN trick. What is the trick, kids? Redo, Redo, Redo. Everyone say Redo. Everyone say Redo, R-E-D-O, Redo, R-E-D-O, Redo. One is ready, I am Redo, ready, Redo. Someone is ready, someone is Redo. We are Redo. Now see, what is Redo? Thank you, thank you, thank you, thank you. Redo. R stands for kids, relative lowering of vapor pressure. Relative lowering in vapor pressure, vapor pressure. So this is one colligative property. E stands for elevation in boiling point. Elevation, something got elevated. Elevation in boiling point. D stands for depression in freezing point, decrease in the freezing point. Elevation in boiling point is getting elevated. Depression in the freezing point is getting down. Depression in freezing point, depression and freezing point. And O stands for osmotic pressure. You must have it studied in bio-osmosis and osmosis, X-osmosis. I will let you know what is osmosis. So this is being osmotic pressure. Gets everyone. These are the 4 colligative properties. Examiner will ask number of questions based on these colligative properties. Redo. Everyone say in your mind, Redo. CP, Redo, CP. What is CP? Colligative property. Redo. R for relative lowering in vapor pressure. It's very tough. So RLVP, you can say RLVP, relative lowering in vapor pressure. Elevation in boiling point, depression in freezing point, osmotic pressure. Now, question arises, what do you mean by colligative properties? Let me tell you, What are these colligative properties actually? What is the meaning of colligative properties? Let me tell you, kids. First of all, everyone is aware of this redo. Everyone say R for, R for, R for relative lowering in vapor pressure, E for elevation in boiling point, D for depression in freezing point, O for osmotic pressure, osmotic pressure. Now, what your HSP Baba says to colligative properties, I never say colligative properties. I never say colligative properties, kids. I always use one term, democratic properties, democrative properties. Now, kids, this we know very well, democrative. Our India is a democratic what? In India, there is democracy. What do you mean by democracy? Let's try to understand what the democracy means. Suppose, kids, if I say, this is Ramu, see, this is Ramu. If I say, this is Ramu, this is Ramu, Ramu's weight is 200 kg. Ramu is having 200 kg weight. This is Ramu. And this is Alia. This is Alia. Alia's weight is just 40 kg. 40 kg Alia. Whose vote is more important? Whose vote is more important? When they are going to give vote, whose vote will be counted more? Alia's vote or Ramu's vote? Ramu is 200 kg, Alia is just 40 kg. Whose vote will have more value? Equal. So vote does not depend. Vote does not depend on weight. Vote does not depend on weight. Vote doesn't depend on weight. Height, color, etc. Weight, this vote does not depend on weight, height, color, etc. Vote depends on number of people only. Vote depends on what, kids? Let me know. Vote only depends on what? Vote is directly proportional to number of persons giving vote. Am I right or not, kids? This means democracy. This is the only meaning of democracy. Am I right or not? This is the only meaning of democracy. That one people means one vote. Am I right? Am I right? This is your colligative properties. Let me tell you, colligative property just means what? Colligative properties are directly proportional to number of particles only, nothing else. Colligative properties, that is your CP, is directly proportional to number of particles. Number of particles, you know particles, what do you mean by particles? Number of moles we can say, number of moles directly proportional to number of moles. We can say directly proportional to number of molecules, because more moles, more molecules. We can say directly proportional to number of ions, number of ions. And colligative property does not depend, I would like to say colligative property does not depend on the type of molecule. CP doesn't depend on type of molecule. Type of molecule means what is the molecule. CP does not depend on what is the molecule, what type of molecule, how many molecules are there, not what type of molecules. Are you able to understand? CP depends on what? CP depends on the type or how many. CP depends on how many, actually how many, not what type, not on what type. That means I would like to say it is not quality dependent, it is quantity dependent. Not quality dependent, it is dependent on how much, how many. Kids, now number of particles. See, let me tell you number of particles. What do you mean by number of particles? See, suppose if I say that I am provided with one solution and this is another solution. Both are having 1 liter glucose. Molarity is 1 molar. Here 1 molar, 1 liter NaCl. Whose colligative property will be more? The A solutions or the B? Which will have more colligative property, kids? A or B? Do let me know. A or B? Everyone do let me know. A or B? The formula of glucose is C6H12O6. Kids, who will have more colligative property? Omar is saying A, Krishna is saying B. Kids, let me know what's your answer. Correct answer is B. Why this is the correct answer, kids? This is the answer. Remember that organic molecules do not ionize. Organic molecules do not ionize. They will be counted as one only. Organic molecules don't dissociate. That means it will be counted as one only. 1 mole means 6.023 into 10 to the power 23 molecules, but it will dissociate and it will become 2 particles, Na positive, Cl negative. This Na means 6.023 into 10 to the power 23 and this Na is 6.023 into 10 to the power 23. So 2 times of Na. Who is having more particles? In the solution? 1 molar NaCl will be having more particles. Are you getting my points? Whose boiling point will be more? Its boiling point will be more. Whose relative lowering in vapor pressure will be more? Its relative lowering in vapor pressure will be more. Whose freezing point, depression in freezing point, whose freezing point will be less? Its freezing point will be less. Whose osmotic pressure will be more? Its osmotic pressure will be more, because all the 4 colligative properties will be more for this. Are you able to understand, kids? Everyone? Now, if I ask one question, kids, this is my question to you. Everyone. Question is, should I ask easy question or tough question? Should I ask easy or tough? Which question should I ask? First easy, then tough. Question is, which will have maximum boiling point? B for boiling point. Option A, 1 molar glucose. Option B, 1 molar urea. Option C, 1 molar sucrose. And if I say 1 molar, option D, 1 molar Al2SO4 whole thrice. What should be answer? Everyone, what should be answer? Do let me know. What's your answer? Hey kids, D, everyone, fantastic. Now, should I make it tough? Should I make it tough? Should I make it tough? Should I make it tough, kids? Should I make this question tough? Okay. See, question is which one is having maximum freezing point? Maximum freezing point. This is the question. Option number A, 0.1 molar glucose. Option B, 0.1 molar NaCl. Option C, 0.1 molar calcium chloride. Option D, 0.1 molar Al2SO4 whole thrice. What's your answer? What's your answer, kids? These are the questions which have been asked in IIT as well as NEET. Already they have been asked. Kids, the correct answer, oh my God, you are really awesome. You people are really awesome. You have given the correct answer. Why? 50% student will give this answer. 50% student will go for D. But this is the correct answer. Depression in freezing point is a colligative property. Freezing point is not a colligative property. Elevation in freezing point is not a colligative property. Depression. So, which one is having maximum CP? This is having maximum CP. And maximum CP means maximum depression. Maximum depression in freezing point means least freezing point. This will have least freezing point, and this is having least CP. That means least depression means it is having maximum freezing point. Am I right, kids? Am I making sense? Are you getting my answer? Are everyone able to understand? Yes, everyone. Now it is whether I talk about NEET or I talk about JEE, their syllabus is same for chemistry. For chemistry, their syllabus is same. Now see, kids. Here is question, an example of colligative. This question has been asked in JEE, AIMS and NEET. Let me know what's your answer. How much efforts your HSP Baba made, kids, just to save your time. And those who have not, smash the like button. Kids, smash the like button. Everyone, kids, hit the like buttons. I want to see your likes. They must reach up to 100. I want to see your likes must reach up to 100. So this is being the correct answer. How you have given this answer? Just follow the trick. Redo. We will follow HSP trick, that is being redo. Relative lowering in vapor pressure, elevation in boiling point, it's not given. Depression in freezing point, it's not given. Osmotic pressure, this is wrong because this is just the freezing point. Must be depression in freezing point. This is just the boiling point, must be elevation in boiling point. Vapor pressure is not a colligative property. Relative lowering in vapor pressure is a colligative property. Redo, redo, redo. Now, oh, here is the question. Another question, kids. Just do let me know what's the answer. Now, let's see. Are you able to give the correct answer or not for this question, kids? Let me check it out. What's your answer? Everyone, do let me know. Hey, kids, everyone, do let me know. Thank you, Samala, thank you. No, two classes will be there. Part 2 will also be there. In the second part, I will let you know azeotropic mixture, Rod's law, Henry's law, all the laws I will let you know. Ideal, non-ideal, Van 't Hoff factor, or I will let you know all the things. Everyone is saying A. Everyone is giving answer A. Kids, just do it once again and try to understand what the question is. Freezing point order of the solution. Freezing point order of the solution of glucose. Are you able to see the questions, the options? Are you able to understand? Try to understand the question, kids. Try to read it properly. Try to read it properly, kids. Once again, read it out, everyone. Now you have switched to B. Kids, everyone read it out properly. 99% students got failed in the first attempt. 99% got failed in the first attempt, kids, because they have not gone through the question properly. The answer is B. B is the correct answer. Why? Freezing point order of the solution. This means this is having maximum freezing point. Why? 1%, 2%, 3%. This is most concentrated. Most concentrated means, kids, most concentrated means more moles. Maximum moles means what, kids? Maximum moles means maximum colligative property, and maximum colligative property means depression in freezing point is a colligative property. That means it will have least freezing point. So who is going to have maximum freezing point, kids? Do let me know. Are you able to understand this thing what I am writing? This will be having least CP. Least CP means least depression. Least depression means, kids, maximum freezing point. Am I right, kids? Am I making sense? Whatever I have told you, am I making sense, kids? Do let me know, everyone. First of all, have you got failed? Now, those who got failed in the first attempt, show me the thumbs down. Those who got failed in the first attempt in this question, so show me the thumbs down. Those who got failed. Everyone, I want to see your answer, kids. So I would like to say this is anaconda question. Am I right? I would like to say this is going to be the anaconda question. This question has proved to be the anaconda question. Am I right? Anaconda means simple but you got failed. Simple but you got failed. Anaconda means simple question but majority got failed. 99% got failed. 99% students got failed. Am I right, kids? Am I right? Now, here is another question. Which of these solutions will have highest freezing point? This time, don't do any mistake. Don't do any mistake and give me the correct answer in the first attempt only. In the first attempt only, I want to see the correct answer, and likes have reached to 91. Make it 100, kids. Make it 100. The first answer I got from Sushma Krishna, Shubha Mega, Definitely your answer is correct this time. Yes, 1 molar. This is having one particle only, one molecule only. It is having two molecules because Na positive plus Cl negative. This will give two molecules, two, and this is Na2SO4. This will give you twice of Na positive plus SO4, 2 negative. This is going to give you three particles, and this is going to give you twice of Al3 positive and SO4, 3 times SO4, 2 negative. So it is giving out 5 particles. If anyone is asking to arrange in the following increasing or decreasing, we can find out how many particles they are going to give. So we can arrange them also. Kids, is it clear to all of you? Till now, is it clear to each and everyone? If yes, show me the thumbs up, everyone. If this is clear to all of you, show me the thumbs up. Now, RLBP, I am moving towards RLBP. Okay. BP means vapor pressure. BP means what? Vapor pressure. And to understand vapor pressure, first of all, you have to help me. Are you ready, kids? If I take this beaker and if I take another beaker, two beakers, and both the beakers, they are having water. They are having water, 1 liter water, 1 liter water. In both the beakers, we are having 1 liter water. Okay. This beaker, the first beaker is at Shimla. It is at Shimla. And this is at, what to say, which is the hottest place in India. Hottest place in India. This is cold place. Cold place. 1 liter water. 1 liter water. Let us suppose the temperature is 20 degrees Celsius. 20 degrees Celsius. Here, which place? Rajasthan. This is Rajasthan. And let us calculate 50 degrees Celsius is the temperature, and this is 1 liter water. This is at 50 degree, this is at 20 degree. Could you please help me? Which water must be boiling? Both or no one? Out of these two, which water must be boiling, kids? Both or none? This is hot place. That is cold place. Which water must be boiling? Second. Kashish has given second. Akanksha has given second. Its answer is no water is boiling, because water boils at 100 degrees Celsius. Neither this water is boiling nor that water is boiling, because water boils at 100 degrees Celsius. So no flask is having boiling water. It's one thing is clear. Is it clear? If atmospheric pressure is 1 degree Celsius, the water will boil at 100 degree. Let us suppose in Shimla it must be boiling at 99 degrees Celsius, but not at 20 degrees Celsius. It may be 100, it may be 99, 98. It depends on the atmospheric pressure. At Himalayas, in Shimla, the atmospheric pressure is less, so water will boil easily, but not at 20 degrees Celsius, 99, 98 like that. Now, could you please let me know which one is forming vapors? This is at 20 degrees Celsius, that is at 50 degrees Celsius. Right now, which is forming vapors? Which is forming vapors? Out of these two, which is forming vapors? Now, this is A, that is B. Which is forming vapors? Yes, kids, which is forming vapors? So somebody is saying none, somebody is saying B. Kids, whatever the temperature is present, vaporization always takes place. Vaporization will take place at 20 degrees Celsius also. Vaporization will take place at 30 degrees Celsius also. See how? If you see mopping, mopping, Bai is doing the mopping, the servants, they are doing the mopping, or you are doing the mopping, and if inside the house the floor is wet, after some time the floor will become dry. We are not giving 100 degrees Celsius. Our clothes, if you just put out it in air, our clothes will become dry. Vaporization always takes place. Vaporization will take place at 30 degree, 20 degree, 10 degree, 15 degree. This is vaporization. Boiling will not take place at all the temperatures, but vaporization always takes place. Kids, is it clear? Vapor, it will form vapor, that will always form, both will form vapors. Whatever the temperature, vaporization will take place. Vaporization will take place. Vaporization always takes place. Vaporization always takes place. But boiling takes place at a particular temperature only. Now, kids, is the difference clear to all of you? In vaporization and boiling point, one point is clear. What is vapor formation and what is boiling point? This point is clear to each and everyone, kids, so that we can move ahead. Now, see. Everyone, what I am going to tell you, now see to it, kids. Everyone. Now, if I say this is one flask and 1 liter water is there. There is 1 liter of water in this. 1 liter of water is there. Water is blue. Let me make it blue, kids. Otherwise, you will say how the water has become red. This is 1 liter water. And if I am giving heat, if I am providing heat, kids, what do you think? Boiling will start or vaporization will be there. Vapors will go like this. These are the vapors, and vapors will eliminate out. Vapors will go out of the system. This is your system, and vapors will eliminate out, will go out of the system. Out of system. Now, kids, if you want to have vapor pressure, what you're supposed to do, just try to keep what? You have to keep something on this, just close it, closed system. This was open system, that is closed system. Are you able to get it? This was open system. This is closed system. Now, kids, do let me know. Now, if you are supplying heat, or even if you are not supplying heat, then also vaporization will take place. Vaporization takes place always. Now, vapors will get formed. Vapors will be there and they will collide with the wall of the container. They will put force. These vapors will put force, and the force acting per unit area, will be known as what? Vapor pressure. Are you able to get it? Kids, everyone, are you able to get it? No exchange of heat will take place. Rethingna, it's not isolated. This I said just closed system. That is an isolated system which cannot exchange matter and heat with the surrounding. I'm not saying this is isolated system. This is just closed system. Kids, everyone got it? Now, let us suppose this was pure water. I have told you pure water, and pure water means pure solvent. Pure solvent. Let us suppose whatever the vapors it has formed, that is P naught. P naught. Whenever I'm going to write P naught will indicate vapor pressure of pure solvent, kids. Vapor pressure of pure solvent. Let us suppose it has formed vapor pressure of X amount, Y amount, whatever the amount. I will say vapor pressure of pure solvent P naught. I will indicate with P naught like this, or indicate with P naught like this. Clear to all of you? Now, kids, if I add, let's see what I'm going to add. Just try to see to it, everyone. If I add this, was the initial situation. I was having flask having what? 1 liter of water. It was having 1 liter of water. In the starting, it was having 1 liter of water, and its vapor pressure was P naught. Now I added solute to this. Just suppose I have dissolved sugar, 2 spoon sugar, 2 spoon sugar to it. Now what will happen, kids? If I'm going to add sugar, sugar is solute, that is being solute. B, this was just solvent, pure solvent, water only. Now kids, it will become solution. This will turn out to be solution. Am I right, kids? Am I making sense? This has turned out to be solution. Now kids, let me write down in that way only, so that you can understand, just to make your understanding proper. Let me tell you, these were the water molecules. Now the sugar molecules, they will come in contact with these water molecules. Sugar molecules will come in contact with water molecules, kids. Are you able to understand? Sugar molecules will hold these water molecules. Now what do you think? This pure solvent was making vapor pressure like this. These many vapors were getting formed, and they were just acting force on the walls. They were colliding with the walls like a Spider-Man. You can consider these vapors like Spider-Man, flying Spider-Man. You know, there is one closed room, and Spider-Man is hitting the wall of the container. Khishak, khishak, khishak. The force acting per unit area. So he will create some pressure, and this pressure will be known as vapor pressure, kids. Are you able to get it? Now, I have supplied some sugar molecules, the solute. Now, solute plus water, what has it become? Solute, sugar plus water has become solution. So I added villain. Now villain is going to capture Spider-Man. Now only few Spider-Man has been left. Now kids, what do you think? There will be, and this solute is non-volatile. Remember that. This solute is non-volatile solute. What do you mean by non-volatile? Non-volatile means that is going to hold these water molecules. If I am going to add volatile solute like ethyl alcohol, then that is going to form more vapors. Then water is going to form vapors, alcohol is going to form vapors, more vapors will be there in the air, then more pressure will be there, because the area is fixed, volume is fixed, area is fixed, so vapor pressure will get increased. So I am adding non-volatile solute. Remember that colligative properties are valid for, yes, dilute solutions, and this should neither associate nor dissociate, and I'm adding non-volatile solute, then only the formula is valid. Yes. Now do let me know, its vapor pressure was P naught, its vapor pressure is PS, vapor pressure of solution. What do you think? Who is having more vapors? This was having more vapors or this will have more vapors. Some Spider-Man got captured. Now only few Spider-Mans will go in the air. Now molecules in the vapor phase were more. Now vapors, less vapors means less molecules striking the wall. So vapor pressure will decrease or increase, kids. Vapor pressure will be less. Very good. So this is known as lowering in vapor pressure. So this was P naught and this is PS. If I subtract, if I write P naught minus PS, this is what? Lowering in vapor pressure. Whatever I am going to get delta P, this is known as lowering in vapor pressure. Lowering in vapor pressure. Now kids, could you help me? Are you going to help me? If I say remaining this much volume only 1 liter, if I keep this volume constant 1 liter only, 1 liter is fixed. Where was 1 liter? This is also 1 liter. If I add 2 more spoon, 2 spoon I have added. Suppose if I add 5 spoons more to this, 5 spoons of sugar. Kids, do let me know, what do you think? Vapor pressure will decrease more or not? Kids, do let me know. There will be more lowering in vapor pressure or not? Kids, everyone, it's your time now. It's your time, kids. More lowering will be there. So can I say that lowering in vapor pressure is directly proportional to concentration, because more and more solute I am going to add. I am adding more and more solute. Solvent is remaining constant. More and more moles of solute I am going to add. That means more and more concentration is getting increased. So lowering in vapor pressure is directly proportional to concentration. Kids, are you getting my point? Now, if I say this lowering, if I compare with the starting one, this lowering in vapor pressure, if I compare with the starting one, this was your lowering in vapor pressure, P naught minus PS, that is delta P. This is your lowering in vapor pressure, lowering in vapor pressure. If I compare this with the starting point, then I will say P naught minus PS divided by P naught. I will say this is relative lowering in vapor pressure. Can I say like that? This is your relative lowering in vapor pressure. RLVP, RLVP kids, RLVP. Now, can I say this is directly proportional to the molality of solution? Can I talk like this? That P naught minus PS upon P naught is directly proportional to what? Concentration. That is, I can write XB, that is equal to XB. What is this XB? This is mole fraction of solute. Mole fraction of solute. Now, what is mole fraction, kids? Do you know what is mole fraction? Have you ever studied mole fraction? Have you ever studied mole fraction, kids? Do let me know. Have you ever studied mole fraction, kids? Everyone, do let me know. Everyone, have you ever studied mole fraction, kids? Oh, great, great, great. That's really awesome. That's really awesome. And this is known as Raoult's law. I will explain you later on. This is known as Raoult's law. Everyone say Raoult's law. Raoult's law. Raoult's law. Now, let me write down this thing, whatever we are talking about, kids. Let me write down P naught. Oh, P naught minus PS divided by P naught is equal to XB. In place of XB, what I can write? I can write NB divided by NB plus NA. Am I right, kids? Can I write like this? Can I write like this? And what is NB, kids? NB is mole fraction of solute, that is weight of solute upon molecular weight of solute. And Na is mole fraction of solvent, that is weight of solvent in grams upon molecular weight of solvent. It's agreed or not? Are you agreed with this or not? This point, one is being solute, one is being solvent. This is I'm talking about solute, and this is I'm talking about solvent. Everyone do let me know. Agreed? Everyone agreed? Agreed, okay. Now kids, if I say the solution is very, very dilute, if I talk about this, if solution is very, very dilute, for dilute solution, for dilute solutions, what we can ignore, this NB will be more or Na will be more. Definitely Na will be more than NB, too much more than NB. Am I right? So can we ignore NB? I will let you know, Alien X. Don't worry, I will let you know. I am the guru of organic chemistry, and now today you are studying physical chemistry also. Now, NB can be neglected in the numerator or denominator. Where to neglect? In the numerator or denominator. If you are going to neglect it in the numerator, nothing will left. So we are going to neglect it in the denominator. But remember that if this is given, then only. What is given? If solution given is dilute, then only you can neglect. Remember that if dilute is not given, you cannot neglect. Neglect only in that condition. If dilute is mentioned, then you can neglect it, and then the formula will turn out to be like this. See the formula, how the formula will look like. P naught minus PS upon P naught will become equal to NB by NA. But remember that this formula is valid only when for dilute solutions only, otherwise not. This formula is valid only for dilute solution. Kids, are you able to understand? Are you able to understand? Now see how to convert it. If I write in place of NB, if I am going to write WB upon MB, and this is Na, in place of Na, see kids, let me make it more clear, otherwise you will get confused. WB MB upon WA MA. Kids, can I write like this? Can I write like this? Now see to it how it will change and how it will proceed. If I write WB upon MB, and if I write WA and MA will come over there. WA will come over here, right or wrong? WA will come there? No, WA will be in the denominator. WA MA, right or not, kids? Is this formula right or not? Right or wrong? Everyone do let me know, is this formula right or wrong? Everyone do let me know, is this formula right? Right. Now see kids, WB then MA. Remember that. In front of WB, MA. In front of WA, MB, WA. WA, then MB. WB, then MA. Are you getting my points? This we have derived, but in the examination you won't be getting that much of time. Just remember, in numerator WB, then MA. In denominator, yes, in denominator WA, then MB. Right? Now see, let me take it to the next page. Let me take it to the next page and see to it, kids. Everyone, what I've told you. I've told you P naught minus PS, and what I've told you, kids, P naught minus PS upon P naught is equal to WB into I don't know upon MB into I don't know. Complete it. Everyone complete it if you know. WB then MA, MB then WA, right? Now, if I multiply this by 1000, then this also have to multiply by 1000. Mathematically, it is correct. Mathematically, is it correct, kids? Is it correct mathematically or not? It is correct. Correct. Now, just see to it, kids. Now, just see to it. WB, MB, WA into 1000. If I take this much, do you remember any formula? Do you remember any formula? This is in gram. This is molecular weight. This is in gram. This is given in grams. This is also given in grams. Can I write any formula for this? This much. Small m. Kids, you got it. Small m. Very good. Wow, this is a small m. So the formula will turn out to be P naught minus PS upon P naught is equal to small m molality into what is left, MA upon 1000. Remember that. Mamma, small m, capital M, mamma, and ma, this is, yes, molecular weight of solvent. Am I right? Molecular weight of solvent. Am I right, kids? Molecular weight of solvent. Now, can we find out the formula for molality? If somebody is going to ask what should be the molality, how to calculate molality. So, the molality will be equal to, yes, P naught minus PS divided by P naught, yes, multiplied by 1000 and divided by, yes, MA. Is it okay or not, kids? Is it okay or not? This is right or wrong, kids? Do let me know. Is this right or wrong? Is this formula right or wrong, kids? Do let me know, everyone. Everyone, do let me know, is this formula right or wrong, kids? I'm asking to you. Now, kids, one more thing. Baba, you are amazing. You are liking it. Now, kids, if. See, I've written this formula, right? I've written this formula. I've written even this formula also, this formula, right? Now see, this formula, each and everything I've written, if I write like this, see, if I write like this, see, kids, if I write P naught minus PS upon PS is equal to WB or NB upon NA. This is right or wrong? Just see to it. This formula, focus on this formula. Let me show you the earlier what I have written. See kids, just see where the change I have done. Just see. We have derived this formula where the formula has gone. Kids, where the slide has gone. One slide is missing, kids, isn't it? One slide is missing, isn't it, kids? We have neglected where that slide has gone, kids. We have done the neglection part. So after this, kids, after this, we have gone to one slide. I can't remember. See kids, one slide is missing. Just see to it. We have started from here. Then P0 XB. Then directly we have got this. Something is missing, isn't it, kids? One slide is missing, kids. So let me write down once again. After this, before this one. So let me write down once again, otherwise it's missing, kids. I don't know where it has gone. Let me check it out where it is given over here or not. Yeah, I think it's given. Wait. Let me take it over here. And this one over there. Now this one over there. Now see kids. Now kids, see. Now it's okay. See, this slide was missing. I was worried about this. See, this slide was missing. And this we have written. Just focus in the denominator. What was there? In the denominator, what was there, kids? In the denominator, there was P0. P0 was there. And what I am saying, there is also P0. In the denominator, there is P0. But what I am saying, if I am going to write like this, kids, now say this is right or wrong, you just focus over here. There was P0, but I have written PS. Is it right or wrong? Can I write like this or not? Anyone? Is this formula right or wrong? What do you say? Is this formula according to you right or wrong? Right or wrong? We have seen, let me compare. Earlier I have written like this. Earlier I was writing like this, P0 minus PS upon P0 is equal to NB upon NA, and I told you this formula is valid only for, this formula was valid only for dilute solutions, valid only for dilute solutions, dilute or very dilute I can write. Now, can I write this also? This one is right or wrong according to you? Now kids, let me tell you the most important thing. This formula works, will always work. Whether dilute is mentioned or not, dilute is mentioned or not. Which formula I am talking about? This formula is always valid. Whether dilute is mentioned or not. Now, how many of you want to know how this formula has come? Is there anyone who is interested in knowing how this formula has been derived? Yes, do let me know. Is there anyone who is interested? How many of you are interested? How many of you are interested, kids? Do let me know. Make it 100. Only 97. 3 more likes to make it 100, kids. Just we are 3 likes away from 100. Okay, see. But you have to make one promise. You have to help me. If you have to help me in deriving this formula, we are going to derive this formula from that formula, right? See. Let's find out. See, kids. Everyone see to it. We are having this formula. We are having this formula. Which formula we are having, kids? Already we are having this formula P naught minus PS divided by P naught is equal to NB upon NB plus NA. Already this formula we are having, right? Already this formula we are having. Now, if I reverse it, if I'm going to reverse it, then see how it will look like. This side also I am going to reverse it, and that side also I am going to reverse it. Just see to it. If I am reversing over here, I am reversing over there. Just do let me know. Mathematically it is going to be right or wrong. I am writing P naught over here. Then P naught minus PS is equal to NB plus NA upon NB. Mathematically do let me know, is it right or wrong? Reversing it. Let me know mathematically it is right or wrong, kids. Everyone do let me know it is right or wrong mathematically. Hey, my dear friends, do let me know mathematically this is right or wrong. Reversing is right or wrong, kids. Do let me know. I have reversed that formula to this formula. Is it okay or it's not okay, kids? Do let me know, everyone. Mathematically right. Now let me do one thing. See what I'm going to do. P naught upon P naught. Can I write like this? No. Let it leave it like this only. P naught upon P naught minus PS. Let me divide it by NB by NB and NA by NB. Can I write like this? Can I write like this? Then what I'm going to get? I will get P naught upon P naught minus PS is equal to 1 plus NA by NB. Just apply your maths. Is it right? Whatever I have written is okay, kids. Do let me know. Everyone do let me know whatever I have written over here is right or wrong. Is this right or wrong? Now, if I bring this 1 to this side, what I will get? I will get P naught upon P naught minus PS minus 1 is equal to NA by NB. I will get like this or not, kids? Till now it's okay. Are you, kids? Even you have to solve it. Just don't wait and watch. If you want to be genius, even you are supposed to go along with me. Is it correct? Just don't see that I'm doing it. You are the one who has to do it. I've told you in the starting only. Just sit with your pen and copy. Now, what I can do? Can I take LCM of it? If I'm going to take LCM, what I will get? If I'm going to take LCM, kids, what I'm going to get? I will get something like this. See to it. What I will get, kids? Yes, everyone help me. I will get P naught minus PS and I know this will be multiplied over there. So I will get P naught and minus of P naught minus PS. Am I right, kids? Is equal to NA upon MB. This is right or wrong? First of all, do let me know, is it right or wrong, kids? The upper one, whatever is written, is right or wrong, kids? There I have written is right or wrong, kids. First I have gone like this, then I have gone like this. Don't forget where I'm moving. I'm moving like this, I'm moving like this. This approach I have turned into this I have turned into this, and this I have turned to this, and this I have turned out to this, kids. Everyone do let me know, am I right or wrong? This one, this one, then this one, then this one, then and this one, then. This is right or wrong? Right. Now what we can do, kids, can I cut like this? P naught minus P naught, this is plus P naught, this is minus P naught. Can I cut it like this? And this minus and minus will become positive PS, will become or not? So let me move on the next page. This minus and this minus will become positive. So let me write down PS, and the denominator, what I am supposed to write? See, kids, in the denominator, P naught minus PS, P naught minus PS, P naught minus PS, and in front of it, what I am supposed to write? See, kids, what I am supposed to write? NA upon NB. NA upon NB. Am I right, kids? Now what I can do? Reverse it. Now on reversing, once again I am going to reverse this formula, reversing it. On reversing it, what I will get, kids? Reverse it. Then what I am going to get? I will get P naught minus PS upon PS is equal to NB by NA. Derived, kids, derived successfully. Can you see, kids? I have proved it. Such a large formula is proved by Baba HSP. This was such a large formula, but we have proved it. We have derived, and this is valid for dilute or concentrated. Always valid. Always valid whether dilute is mentioned or not. Dilute or not. Now, in your school also, everywhere you have to use this formula, kids. Kids, everyone show me the thumbs up. Oh my God, it has been reached more than 100 likes. Kids, are you liking Baba HSP's teaching? For you kids, for the first time I am teaching this physical. I was teaching organic only, and for you, I have been teaching for 23 plus years, but for you kids on this channel, for the first time, I have taken the first lecture of physical chemistry. This is the first lecture I'm going to take of physical chemistry. Are you liking it, kids? Now, always use this formula, P naught minus PS upon PS is equal to NB by NA. Now, see, kids. This formula is known as RLBP, relative lowering in vapor pressure. Now, kids, let me give you one question based on this. Let me show you one question. One easy, then one tough. This is easy. Easy question. Try to solve it. Then I will give you one tough question, kids. Thank you, Joseph. Thank you. Thank you. Thank you. Thank you. I'm so happy and learning physical chemistry like this first time, Baba. Thank you, Asif. Thank you. Kids, first of all, if you're liking my organic, my physical, my inorganic. I will tell you inorganic also. I will let you know. Everyone, it's your duty to share it to maximum. Baba is teaching on your online platform. I'm new to this platform. Otherwise, offline for the 24 years, means 23 plus years, I have been teaching, produced number of ranks. But on YouTube, YTube, I'm new. I'm new for this English Unacademy channel. It's your moral duty to share it to maximum people, kids. Madra Ucha. Thank you. Thank you. Now, this is your question. Let me move aside so that you can solve it easily, kids. So that you can solve it easily. What's your answer? Do let me know, kids. Everyone, you have to help me with the answer. Everyone. Yeah, this channel is a great gift. Shri, Shri, Shri Kate Pogu. Do let me know the answer. Everyone, I'm waiting for your answer, kids. Hey everyone, do let me know the answer. I'm waiting for your answer, kids. Okay, you are taking too much time. Should I solve for you? Should I solve it for you, kids? Now see how to do it. One thing we should know very well. One thing we should know very well, that one atmosphere. One atmosphere means what, kids? One atmosphere is equal to 76 centimeter of mercury, right? Or we can say 760 mm of Hg, or we can write 760 torr, or we can write 101325 Newton per meter square, or we can take roughly 10 raised to power 5 Pascal, or we can say 10 raised to power 3 kilopascal. Am I right, kids? Am I right for these units? Are these units correct, kids? One more thing I would like to say, that here in this most of the students are confused. One atmosphere is equal to, this is actually not final torr. One atmosphere bar, how many bars? This is okay. One atmosphere is equal to how many bars? I hope that everyone is getting confused over here. How many of you want the HSP Baba trick to solve this? One atmosphere is equal to how many bars? Kids, how many of you want to know the trick? 1 by 76. Let me come to that. 1 by 76. Some students are writing 1 by 76. How many of you want the HSP Baba's trick for this? HSP Baba's trick. Yes. How many of you want kids HSP Baba's trick for this? Do let me know, then I'm going to give you. Just see. Just see. Everyone see to it. One atmosphere. You write like this. Atmosphere. Just see. Focus over here. A is looking like 0. So I will write 1 point. A is looking like 0. T is looking like 1. And M, if you do like this, M, if you write M like this, it's looking like 3 bar. Bar. This is the answer, kids. 1 atmosphere is equal to 1.013 bar. Now, You may get confused. You may get confused that which one is having more value. So the guard standing on ATM is having more pressure, or the guard standing in front of bar is having more pressure. Which guard is feeling more pressure? See, in ATM there is money, too much money, and in front of bar, you know, the guards, they are not having that much of pressure. Whose value is more? ATM. This is more important, more valuable, more value, more value. This is having more value, kids. This is going to have more value. Are you getting my point? More value, more value. You liked my trick? Have you liked it? Everyone, do let me know. Next, now see, kids, what answer you have given? What answer you have given for this? What answer you have given, kids? A, B, C, D. Oh, 7. It's not 7. It's C. A, B, C, D. What's your answer, kids? What's your answer? See how to do it. We know the formula. This is given dilute. So whenever is dilute is given, we can apply the formula. Which formula, kids? Whenever dilute is given, we can apply P naught minus PS upon P naught is equal to what? Is equal to NB upon NA. Can we use this formula, kids? Can we use this formula? Yeah. So this formula will turn out to be like this. WB upon MB into, yes, MA upon WA. Am I right? Now this is P naught. So can I write the values? P naught 760. See from where 760 we have got 760. This 760. So we can write 760 minus PS. What should be PS? The vapor pressure of aqueous solution of glucose is 750. 750. We can write 750, right? Okay. Now divided by P naught. How much is P naught? 760. How much we will get over here, kids? Now the vapor pressure of dilute aqueous solution of glucose is this much. The mole fraction of solute. So this no need to write. This is just, we can write mole fraction of solute. No need to write this. This was mole fraction of solute only, kids. So this is equal to XV. No need of writing that. Just subtract 760 minus 750. This will come out to be 10 upon 760 is equal to that XB. So XB, how much is the value? 001 upon 76. You got it, kids? Everyone got it? Kids, how was the question? It was oral question. It was oral question or not, kids? It was just, you can do it in the air. It was just 760 minus 750 was 10 upon 760. So it was 1 upon 76. This was just, you can do it in the air. And this question has been asked in JEE exam as well as AIMS exam. Simple question, but kids, many of you got failed. So it's the question of JEE as well as NEET question as well as JEE question, kids. Now, those who have not taken admission for JEE as well as NEET, that is the Avengers 2.0, there are chances you can enroll over there. Now, see, kids, now tough question, rank deciding question. It will require some time. Would you like to try? It's a rank deciding question. It will take some time. Now you can see too much calculation is over there. Would you like to be solved by yourself or should I help you, kids, in this question? Copy it. Everyone, do let me know. Should I solve it for you or would you like to do it yourself? They are asking about the molecular weight of solute. Should I solve it for you, kids? Okay. Okay. Now see, kids. The formula we know, nowhere dilute is given. Which formula we have to use? In this question, dilute has not been mentioned. Once the dilute word is not mentioned, which formula you're supposed to use? Which formula you are going to use, kids? We have to use this formula, kids. We have to use this formula. P naught minus PS upon PS is equal to WB upon MB into, what should I write? MA upon WA. Am I right, kids? If you remember this formula we have derived actually. If you remember this formula, we can solve this question. Now, what they are saying, what they are writing, just focus over here. They are saying, according to these people, the questionnaire, vapor pressure of benzene at 90 degrees Celsius is 1020 torr. At solution of 5 gram, a solution of 5 gram of solute in this much gram of benzene has a vapor pressure of this. That means pure benzene, the pure benzene, this P naught value is 1020. Am I right? 1020. 1020 I can write, minus solutions 990. I can write 990. Then I will draw the line PS 990. I have to write over here. Now in front of this WV, benzene 58.5. I have to write 58.5 over here. I have written 58.5. Now solute MB is missing. MB is missing. That they are asking. MA, benzene is this C6H6. So 12 6 72 and 6 hydrogens 78. This will come out to be 78. So in place of MA I can write 78. 78 I have written, kids. It's gone over there. Let me write down here into 78, kids. Now WA weight of solvent 58.5. 58.5. Are you getting, kids? 58.5. Let me write down here because it's too much congested over there. So let me write down this thing over here. Whole thing I'm going to write down over here. That what's WB? WB was, kids, WB was weight of solute how much? 58.5 gram of, no, this was the pure solvent. Where the solute? 5 gram. 5 gram is solution of 5 gram of solute. 5 gram upon WB upon MB. MB, we don't know what is the molecular weight of this solute. That we don't know, that is missing. So I have written MB. Now in front of WB I will write MA. MA is 78 and divided by 58.5. The values I have written properly, kids, otherwise we won't be able to solve it. The values I have written correctly, kids. Kids, all the values, whatever the, oh my god, Shubha Muthi Krishnan, congratulations, your answer is absolutely correct. Oh great. Now first of all, do let me know whatever the values I have written, they are correct or not. Are they correct or not, kids? These values are correct or not? Properly I have written WB, MB we don't know. Now we are supposed to calculate MB. Just let me know what it will come out. 100,10,20,998 will come out 30. So let me take it roughly. So I will take, this is 30 and this is, let us suppose 1000. Rough. 578, I can take 78 to be 80. So I have taken 5 into 80, and this MB, and this 58.5, I can take 60. 60, can I take it to be 60? 60. Now our calculation will become easy. 6 3s are 18, 1800. So it will come out to be MB is equal to that 5 into 80 into 1000 divided by 6 into 3 into 0, or 10 into 10. So these 10 and 10 will cancel out. 10 and 10 with this will cancel out. Now 6 3s are 18, and this is how much? Let me cancel out. 6 3s are 18, and 3 3, it got cancelled out. What is left, kids? What is left? Something is missing, kids, I think. Something is missing. Something is missing, I think, kids. What is missing over there? I missed something, I think. Let me do it once again on the press page, because too much congested is this. Kids, this is over here, this will come over here, then see how much we are going to get. Everyone solve it, then I will let you know the next page. 219.8, yes, you are getting. Now let me do the calculation, rough calculation, how to do the rough calculation. See, kids, MB, we are supposed to find out MB, this will be 5 into 80 into 1000. We are going to take 5 into 80 into 10 raised to power 3 divided by MB. So 5 into this, and 6 into 3 into 100. So in the numerator, what we are, this is going to address for 1, 580 and 18. 580 divided by 18. You see now how much it is coming. 18 twos are 36. Twos are 2 point means 2 and something, that that 0 is there. So definitely what you are going to get, kids, 1 0 is more over there. I think 1 0 is more left over there, kids. 0, yeah, one more 0. Kids, clear to all of you? Everyone do let me know you are getting the answer, kids. Everyone just see to it. Are you able to get the answer? Kids, do reply that everyone is getting. If 2 is coming out, no other option is starting with 2. Only one answer is starting with 2. Kids, you got it? Just reply that everyone is getting the answer or not, kids. Hey, everyone, do let me know that such a huge question, you are going to solve it within seconds. Everyone is getting the answer. Fantastic. Now see, elevation and boiling point. What is boiling point, kids? First of all, do let me know. It's more than 2.5 hours gone. Are you full of energy, or you need break? Are you full of energy, or you need some break, kids? First of all, do let me know. Everyone, hey everyone, reply please. You need some break, or you are full on energy? No problem. Wow. Okay, I will solve it. Buddha Surya, don't worry, Buddha Surya, I will solve it. See, wow, Vedha Janani, wow, full on energy. Now see, what is boiling point? See, kids, what is boiling point? Let me tell you. With the graphical representation. I'm going to show you what is boiling point. See, kids, if I tell you the x-axis and the y-axis. On x-axis, if I am taking temperature in Kelvin, temperature in Kelvin or degree Celsius, whatever you're going to take, and here I'm taking vapor pressure. On this line, if I'm taking vapor pressure, it's in our normal area. What is the atmospheric pressure? I'm not talking about altitudes, hilly areas, mountains. At our land place, what is being the atmospheric pressure? What atmospheric pressure we are going to take? Atmospheric pressure is, yes kids, that is being 1 atmosphere. This is 1 atmosphere, the normal atmospheric pressure, 1 atmosphere, right kids? 1 atmosphere, 76 centimeter mercury or 760 mm of mercury. Neat. Okay. Yeah, fantastic, Newt kids. Fantastic. I'm coming to that. Let me take water. I'm going to take water. I've taken water, right? Kids, I took water. This is water. Pure solvent, right? This water is pure solvent. Water is pure solvent. Now, kids, if I say the temperature right now is 10 degrees Celsius, what do you think? It should be having some vapors. At 10 degrees Celsius, this water must be forming some vapors or not? Agreed or not? At 10 degrees Celsius, this water must be forming some vapors or not? Yeah, it must be forming some vapors. Let us suppose the water is forming these many vapors. These many vapors, the water is at this point, suppose this point. And if I am increasing the temperature, if I keep on increasing the temperature, kids, what do you think? Vapor pressure will, vapors, more and more vapors will form or less vapors? If I am increasing the temperature, vapors will increase, and more vapors means more vapor pressure. More vapors means more force. More force, area is constant. Area is constant. More force acting per unit area, more pressure, and this pressure is formed due to vapors, so more will be the vapor pressure. Am I right? Am I right, kids? So if I keep on increasing temperature, the vapor pressure will keep on increasing, will keep on increasing, will keep on increasing, will keep on increasing. Ting, 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 ting. A point will reach where this vapor pressure is going to touch, that vapor pressure is going to touch the line where atmospheric pressure is lying, kids. This particular point, the point at which vapor pressure of this liquid becomes equal to the atmospheric pressure, this temperature is known as what, kids? This temperature is known as boiling point. This is the boiling point of water. This is the boiling point of water, kids. That is 100 degrees Celsius. 100 degrees Celsius. Are you able to understand, kids? Is everyone able to understand? This much is clear to each and everyone, kids. So, if I make the same thing, kids, see, if I talk the same thing at high altitudes, if I make it at mountain area, suppose if I am talking about at mountain area, what do you think? In hilly areas, the atmospheric pressure is less or more? If I talk about hilly areas, the atmospheric pressure is more or less? Less. So this, if I say this is hilly area, and let us suppose in Shimla, if I say in Shimla, the atmospheric pressure is, let us suppose, 0.9 atmosphere, 0.9 atmosphere. Now the water will start boiling in a hilly area. The water will start boiling at 100 degree or less than 100 degrees Celsius. At 100 degree or less than 100 degrees Celsius, let us suppose 95 degrees Celsius, the water has started boiling. Are you getting my point? In hilly areas, water will start boiling first at low temperature or high temperature? Now, there is one question. I will let you know that question, that why rice requires more time to get cooked at high altitudes. Whenever we are at mountains, the rice will require more time to get cooked. That is the question that I will explain later on. But right now I am interested in telling you elevation in boiling point. Now see kids, if I talk about elevation in boiling point, just see to it. If I talk about elevation in boiling point, if I talk about elevation in boiling point, so to our pure solvent, if I am going to add some solute, if I add some solute to this pure solvent, then that non-volatile solute, just like sugar, I'm adding sugar to it, then it is going to capture some solvent molecules. Now some solvent molecules are captured by solvent. Now the Spider-Man are solvent, where the Spider-Man, they were moving like hitting the walls of the container. Now I have added villain. That villain is going to capture this Spider-Man. Now more Spider-Man molecules won't be able to fly. They won't be able to hit the walls of the container. Now less Spider-Man, less volatile molecules of the water solvent are hitting the walls of the container, that is the vapors. The force will get decreased because the area is remaining constant, because the volume is constant. So less molecules are going to hit the walls, less will be the vapor pressure. So vapor pressure of solution, this is sugar I have added. So this has become now solution. Now it has turned out to be the solution. Now let me know, this will be more or less, solution's vapor pressure will be more or less, kids. Solution vapor pressure will decrease or increase, kids. Solution's vapor pressure will increase or decrease, kids. Do let me know. Definitely it is going to get decreased. So let me take, this is the line for vapor pressure of solution. This is the line for vapor pressure of solution. So let me make it more proper so that you can understand, kids. This is the line for vapor pressure of solution. Just see to it. Now at what temperature, first let me indicate what I have written. This is vapor pressure of solution. This is pure solvent line. This is solution line, and that was pure solvent line, pure solvent. Vapor pressure of pure solvent, vapor pressure of solution. Now this will start boiling at this temperature. At this temperature it is going to boil. Let me write down whatever the temperature, any temperature. Suppose if I am writing 103 degrees Celsius. So this gap, kids, this much of gap is what? This much is gap is what? This is elevation in boiling point. You see clearly, this is elevation in boiling. This gap 100 and 103, that 3 degrees Celsius, so whatever the temperature, delta TB, I will write delta TB. This is known as elevation in boiling point. This gap is actually the elevation in boiling point. If you are able to understand, let me tell you, kids, in another slide so that you can clearly observe it. So this gap is, kids, elevation in boiling point. This delta TB, the delta TB is the elevation in boiling point. Delta TB is elevation in boiling point. Elevation in boiling point. Now kids, if I add more sugar to this, then what will happen, kids? If I add more sugar to it, just see what is going to happen, kids. If I add more sugar to it, kids, let me know. If I am going to add more sugar to it, then what will happen, kids? Suppose if I am going to add more sugar, to it, then these molecules will get captured. more molecules will get captured. Now less water molecules will form vapors. Who is forming vapor? The water molecules, the free water molecules. So the free molecules of the solvent, the molecules which are free, which are not captured, which are not in contact with the solute, they are easily forming vapors. Earlier pure solvent was there, more vapors were formed. I added solute, some molecules of water or the solvent got captured by solute molecules, less molecules of the solvent are going in the vapor phase. Now I am going to add more non-volatile solute, more molecules, they are going to capture the molecules of the solvent. Now less vapors, less vapor pressure. Now less vapor pressure. So this is solution number one. And if I say, if I'm going to increase the concentration, now this will become more concentrated and this will start boiling over here. Kids, if you are able to get it, if you are able to understand, then do let me know. Now it will start boiling, over here at this point. Now how much gap is there? Can you see, kids? Can you see how much gap is there? If you see, you will come to know now more elevation in boiling point, this much elevation in boiling point. You can see this much is delta TV. So more and more solute I am going to add, more and more boiling point is getting increased. So more elevation in boiling point is there. The thing of that solution, the more and more concentrated solution will boil at more and more high temperature. So this is directly proportional to the concentration. So I would like to say that delta TV, elevation in boiling point, is directly proportional to the molality small m. And if I remove this proportionality sign, then I will say delta TV is equal to kbm. kbm, kids. This is new formula for you, kids. This is new formula, and this formula is for elevation in boiling point. Remember this formula, delta TV is equal to kbm. I'm going to tell you what is kb. What is kb? I'm going to tell you, kids. First of all, do let me know. Are you able? It's 1 o'clock. Oh my God, 3 hours has been passed and you kids are that much energetic. Kids, I will require just half an hour more, kids. But yeah, really I am giving you lot of thanks from the internal core of my heart, kids. Really, you're liking my teaching. This is the first time on this platform I'm teaching physical chemistry, kids, and I'm liking your love, kids. Really, may Almighty God bless you with all happiness and prosperity, along with the best rank, kids, best knowledge. How much you are liking, first of all, do let me know. You have to write in the comment section once the video is getting over. But right now, do let me know each and every point. Are you able to understand? First, do let me know so that I can understand. I'm not teaching physical chemistry for the first time. I have been teaching physical chemistry for the last 23 plus years. But what I'm saying, over here on Unacademy NEET English channel, this is the first time I'm taking this lecture for the first time, solution chapter for the first time. First of all, do let me know, everyone whomsoever is watching this video, and hit the like button, smash the like button, kids. Do let me know your feelings. Are you able to understand, properly able to understand each and every point, even the minute points you are able to understand, kids? Wow, Piyush Nemi, maja aa raha hai. Wow, that's really fantastic. Really giving. Shubha, we love your teaching, Baba. It's hard to find a teacher. Oh my God, thank you. Thank you from the bottom of my heart. Crystal clear. Wow, so super God of chemistry. Wow, merciful. Yes, now see, kids. See, everyone. Delta TV is elevation in boiling point. KB is abelioscopic constant on molar elevation constant, and this is M. Let me tell you. Let me tell you on the fresh page. Let me tell you on the fresh page, kids. See, delta TV is equal to kbm. Delta TV is equal to kbm. So what are the meanings? We have to know the meanings of all these things, otherwise it's useless. See, delta TB is elevation in boiling point. Elevation, everyone say along with me, elevation in boiling point. That is our colligative property. Now kids, KB is molar elevation constant. Molar elevation constant. Elevation constant. Now it is also known as abelioscopic constant. Everyone say this is going to be asked in your examination. Say abelioscopic constant. Abelioscopic constant. It is a tongue twister. You can take it as a tongue twister. Say everyone, abelioscopic constant. Abelioscopic constant. Generally, its value is 1.86 Kelvin kg per mole, and M is your hero. That is your molality. Molality, kids. Molality. Now, if you are familiar with this formula, now you can do anything, you can find out anything. Number of times they can ask even the weight of solvent. So this formula can be extended. See how this formula can be extended. See to it, everyone. They can ask question based on this formula like this. See kids, delta TB is equal to KBM. In place of M, what we can write? Delta TB is equal to KB. And how to write M? In place of M, this M we can write WB, weight of solvent in grams, upon molecular weight of solvent, weight of solvent in grams into 1000. This is your molality. In place of molality, we can write like this. Now kids, if anyone is going to ask what is the molecular weight of solute, we can find out molecular weight of solute by this formula. This formula will work for that. Everyone, Shorts Tamilian, very wonderful day today. I'm happy to watch this video with my friend. Thank you. Thank you. Now you can find out molecular weight in this way. Molecular weight of solute can be obtained. Molecular weight of solute can be obtained. Now kids, before I move towards any question, the question arises, why? Brilliant question. Everyone try your best efforts. Why water boils at low temperature? The question is, or high temperature. What's your answer? Just see the question first. Why rice needs more time for cooking at hilly areas. So how will you define, kids? How will you define this question's answer, kids? Should I let you know? Wow, that's really nice, Buddha Surya. Now let me tell you, kids, see what happens. Kids? This is, let us suppose this is pure water. This is being pure water. Just suppose we are having pure water. Right now, let us suppose we are present in Tamil Nadu. Right now we are in Tamil Nadu, and we are going to cook tomato rice. We are supposed to cook tomato rice. You know tomato rice. Now what we will do, we'll put some tomato, we'll put some rice, we'll add some rice to it, right? We are going to add some rice to it, and we will supply some heat. We will supply some heat. Now kids, as we are supplying heat to this water rice, the water is taking heat and water is giving heat to the rice. Heat is taken by water, water being liquid, and water is supplying that heat to rice, and rice is absorbing heat, and rice is getting heat. That rice is getting cooked by getting heat, okay, and water will start boiling at 100 degrees Celsius over here. Now if I talk at mountains, see what is going to happen at mountains. If I talk about mountains, hilly areas, then the same water, same rice, and same heat we are going to supply. Now kids, what happens? Only some amount of heat water is going to supply to rice. Water will provide heat to rice, and not at 100 degrees Celsius. It will start boiling at suppose 98 degree or 97, whatever the pressure is there, 96 or 90 degrees Celsius. I cannot say. Even at these many degrees Celsius, water will start boiling, and once the water is boiling, kids, what will happen? It will supply some heat to rice, and some heat it will use as latent heat of vaporization, and that heat will be supplied for change, for transformation of state. That heat is getting divided in this case at hilly areas. I would like to say at hilly areas, what is going to happen, kids? At hilly areas, what is going to happen, kids? At hilly areas, heat is divided in two parts. Heat is supplied to the rice. As well as heat is used for phase transition. So kids, rice is getting less heat, that is for boiling. This is for boiling purpose. Now kids, rice is getting more heat or less heat. In this way, rice is getting less heat. Rice is getting less amount of heat. Are you able to understand, kids? Is this point very much clear to all of you? Wow, Raja is writing, I love your method of teaching. Thank you, Raja. Your words means a lot, and thank you for noticing my efforts. Really, I'm liking it. Now kids, are you able to understand why at hilly areas rice they are getting more, they are in need of more temperature? So heat is getting divided in two parts. That's why rice, they will say, oh, what's this happening? You are sending this heat for your phase transition, for transformation. You are wanting that you should convert from liquid to gas, and you are not providing that much heat to me. So rice is very unhappy with the heat. Rice is not happy with the heat. Rice is saying, what are you doing? Hey man, a heat. You are just providing heat for phase transition. You want to transform yourself. You're not giving it that much of heat. It's not fair. Sir, have some water. Oh, Kashish, thank you. Let me have some water. Thank you, Kashish. Really thanks for taking care of your teacher. Oh my God. Meanwhile, kids, hit the like buttons. At least make them to 120. It is 111. See what the great figure. 111. 1, 1, 1, triple 1. See, break the size of 1, 1, 1. Now, thank you. Now, see, kids, let me tell you one more thing, that I have written one formula. Just see, kids, this formula I have told you, delta TB is equal to KBM. This KB was abelioscopic constant, as I have told you. This KB is abelioscopic constant, and this KB's value, KB depends only on type of solvent, type of solvent, type of solvent. That's why we are calling it constant. For every solvent, it will have constant value, and its value can be determined thermodynamically. Thermodynamically, see how? Thermodynamically, its value can be determined. The formula is KB is equal to A for solvent, RTB whole square upon 1000 into change in enthalpy of vaporization. This is the formula, kids. Number of times they can ask you in the match the following. They can ask you this formula, so we have to remember this formula. This is the formula for finding out value of KB. Everyone, see to it what I am telling you. This abelioscopic constant can be determined through this formula thermodynamically. Abelioscopic constant. Now, kids, it will require just 15 minutes more, not more than that. Kids, are you ready to put your efforts for 15 minutes more? Only 15 minutes more, kids. Only 15 minutes more. Yeah, Ma is molecular mass of solvent. Ma is molecular mass of solvent. Ma is molecular mass of solvent. And R, you know, gas constant. R is gas constant, 0.0821 liter atmosphere per Kelvin per mole, 8.314 joule per Kelvin per mole, 8.314 into 10 raised to 7 ERG per Kelvin per mole, 0.02. Okay, now you know. Now, kids, this TB, you know, boiling point, and this is in change in enthalpy of vaporization. You know the meaning of all these things. Kashyap size thinks, sir, is there any trick to memorize this formula? Okay, let me make this trick. KB is Kabir. Kabir is in bookmart. Bookmart, you know, bookmart. Kabir is in bookmart, at the tea stall of bookmart, or bookmart tea stall. See, Kabir is at M-A-R-T and then T. So 2 times T, mart. Or you can form Kabir mart tea stall divided by 1000 times enthalpy of vaporization. Kabir mart, Kabir mart, KB mart. How to remember this formula? See, kids, this trick, KB mart T, KB mart T. See, KB mart T. Let's make it out, the formula KB mart T. KB mart T into T, BB. KB mart T, BB, KB mart TT, KB mart TT, TT is table tennis, KB mart TT, BB, KB mart TT, BB, divided by 1000 1000 H. What is H? What can be called H? So everyone say KB Mart TT, KB Mart TT, BB. B boiling point. If you're not saying B, then it's okay. KB Mart TT. Everyone say KB Mart TT upon 1000 H. H, I don't know how to remember H in the denominator H. You have to learn it. Otherwise, KB Mart TT, KB Mart TT. Okay, will you be able to learn it? Kashish Shah, KB Mart TT. Thank you, thank you. Now see kids. Here is the question. Just try to do it. Let me check it out. This time you are going to get correct answer or not. See, it's too close. It's too close. Thank you, Kashish. Thank you. Yes, B. Somebody is writing C. Somebody is writing B. What Kabir Mart in tea stall. Now, neat quest. I made one more trick. See. Meanwhile, I was making one trick. See. Maruti tire. Maruti tire. And Maruti, you know Maruti? Maruti is a car. Maruti is Hanuman also. Hanuman. You know Hanuman. It's you know Hanuman. Hanuman is the base. You must have seen Ramayana, movie Ramayana. Maruti tire, M-A-R-T, Maruti tire, and the base is Hanuman, 1000 Hanuman, 1000 Hanuman, Maruti tire. And this KB I don't know, M-A-R-T, Maruti tire, and Hanuman is the base. Hanuman is the base. Maruti tire, Hanuman is the base, and KB I don't know. KB, you make KB something, kids. Maruti tire, Maruti tire. Maruti is the car, Maruti tire, and at the base is Hanumanji. KB I don't know. Kids, just make for KB. This is going to be really the awesome trick. Maruti, M-A-R-T, Maruti tire, base is Hanumanji, 1000 Hanumanji, and KB is in Ramayana, KB is anything, Baba, B for Baba, K for anything, kids, K for anything. K, anything from the Ramayana, K starting from K, any character, K starting from K, kids, Bhim, Arjun, Yudhishthir, Ravana, no one. Kids, just find out KB, otherwise Maruti tire. Now, what's the answer, kids? Krishna, oh, yes. Krishna Baba. Krishna Baba is equal to, yes, you made it. You made it. Kamba Ramayana. Oh, Ashwat Kambar, who wrote Kamba Ramayana. Yay. King Baba. King Baba. King Baba is equal to Maruti tire upon 1000 H. This trick is completed. King Baba or Kambara Ramayana is equal to Maruti tire. This trick is complete. Should I write over here? King Baba. King Baba. Maruti tire. Maruti tire. 1000 Hanumanji. 1000 Hanumanji. 1000 Hanumanji. 1000 Hanumanji. Hanuman. Hanuman. It's completed. Completed, kids. Completed. Yes, Swati. Yes. This is the talent. This is the talent. Now, solve this question. Everyone, solve this question. Now, I'm going to solve it. See, kids, what's the answer we are going to get? An aqueous solution containing 1 gram of urea. Urea is NH2. Let me solve it on next page so that your notes should remain clear. Let me copy it. Let me first copy it. Now, see, kids, everyone see to it. We know that urea is NH2, CONH2. So kids, nitrogen is 14. 14 2s are 28. For nitrogen, we are getting 28. I am going to find out the molecular mass. Hydrogen, 4 hydrogens, so 4. And 1 carbon, that is 12. 1 oxygen, that is 16. Just add it. 8, 4, 12 to 14, 6, 0. And here 2, 1, 3, 4 and 5, 6. 60 is the molecular mass of urea, right? Because glucose, now glucose is being C6H12O6. 180 is the mass of glucose. So kids, boils at this much, delta TB. What is the value of delta TB? The value of delta TB is 0.25 degrees Celsius. 0.25 degrees Celsius. Now, the aqueous solution contains 3 gram of glucose. So kids, we were having what's the molality? Its molality should be 1 gram upon 60, and whatever the solvent in kg, that is remaining same. Volume is remaining same. Now, that is 1 by 60. Now, if I talk about this glucose, then this should be, molality should be 3 by 180. 3 by 180 and 3 by 180, and the volume is remaining same. Where the same volume is remaining same. So 3 by 180, that will come out 1 upon 60 only. 1 upon 60 in volume will remain same. Same means same elevation in boiling point. So the answer will remain same. C will be the answer, kids. Is it clear? Because molality is remaining same. So the elevation in boiling point will remain same. And the volume is same. So the solvent is same. So same answer. Everyone got it, kids? Everyone got it? Now, let me see to it. Another one. Depression in freezing point. We are moving towards depression in freezing point. Let me tell you, kids. Now, not too much time we are going to take. Only in some time we are going to complete it. Once again, I am writing temperature and vapor pressure. On this y-axis, vapor pressure is increasing. Here, temperature is increasing, and this is our atmospheric pressure, constant atmospheric pressure. So this much is 1 atmosphere constant. Okay. Now, in the starting, we have drawn one thing. that is the solvent. If I am having pure solvent, it was, I have told you, this was water's boiling point. The water was boiling at this temperature and this was 100 degrees Celsius. We have already seen. Now pure water, if I am having, if I draw this line, I have already drawn, this is the liquid line, liquid. Now you will say, sir, how liquid? It is forming vapors. So the liquid was forming vapors. So the state is liquid. Now get C. The point where this line is going to touch, this solid line, this is solid phase, kids. This is being solid phase. And this temperature, this particular temperature, kids, where these two lines are touching, these two lines, let me make with another color so that you can easily find out. This line where both the faces are touching, this line is known as freezing point. This was known as boiling point. This earlier one was known as boiling point, kids. This was your boiling point. Temperature, this temperature was boiling point. This temperature was boiling point. This temperature was boiling point. Now this is your freezing point of pure water. This was the H2O's liquid phase. This is H2O's solid phase, and this point where two phases are interacting, this is known as freezing point. Kids, where both the phases are touching, that temperature is. Kids, now see, if I draw the same graph for solution, when we are going to add some solute to this, how it will look like. This was pure solvent. Now if I am going to add solute to it, now we have already seen, kids, this line was like this. There was elevation in boiling point. You have seen already there was elevation in boiling point. Kids, have you seen or not? There was elevation in the boiling point. This already we have seen that there was elevation in boiling point. This already we have seen. This line was indicating that this much elevation was there in the boiling point, kids. This much was the elevation in boiling point, and this line is indicating that this much was the elevation in boiling point. This was the elevation, kids, right? Now how much this line, now when this line is going to touch this solid line, this and this point, if I say this point, this depression, this is the depression in freezing point. This is delta TF and delta TF, and more if you go add this, see, more and more solute you are going to add, more and more depression in freezing point and more elevation in boiling point. That side elevation, this side depression. You are getting my point? This side more and more elevation in boiling point is going to take place. You can see clearly that more and more elevation in boiling point is taking place, and this side more and more depression in freezing point is taking place. So the freezing point will get decrease. Veera level, sir, thank you lot of sir for giving helpful teaching. Thank you short Samil. Now see, delta TF is directly proportional to molality. So I would like to say that delta TF is directly proportional to molality, or I can say delta TF is equal to KFM. Now what are the meaning of these things? Delta TF is equal to KFM. Now see, delta TF is depression in freezing point as usual, like delta TB, depression in freezing point. Depression means, now let me tell you the practical way. If you just try to freeze out water into ice, it will take just 2 hours or 3 hours. But if you add some milk, or you want to prepare kulfi, ice cream, take milk, add some sugar to it, some dry nuts, and whatever the things you are going to add, it will require more time, 6 hours, 7 hours. More and more things you are going to add to that solvent, more and more time it will require to get freezed. And that's why the thing which is highly concentrated will require more time to get freeze, because there will be more and more depression in freezing point. Thank you, Buddha Surya. So depression in freezing point, and this is cryoscopic constant. Everyone say cryoscopic constant. Cryoscopic constant. Everyone say cryoscopic constant. That was abelioscopic constant, and this is cryoscopic constant. Everyone say cryoscopic constant. This is very, very important. That was molal elevation constant, and this is molal depression constant, or you can say molal depression constant. Molal depression constant. Molal depression constant. Now this is your hero. Molality. Molality is the hero, independent of temperature. Mole fraction is also independent of temperature. So this is your formula. And thermodynamically, how to find out its value? Everyone hit the like button, kids. It's only 140 and make it 120. Now thermodynamically, how the value of Kf can be obtained? I have told you right now the formula thermodynamically, how to find out its value. Thermodynamically, kids. Yes, Kb, King Baba. What was the formula for that thermodynamically? How we got that was dependent on solvent, and its value is also solvent dependent. Solvent dependent. This is solvent dependent. Now, kids, King Baba. What was the formula? King Baba. So apply here King Baba. King Baba, that in place of Kb will write Kf. Yes, Maruti, M-A-R-T-T. In place of B there will be F. F, Maruti, 1000 enthalpy of fusion. In place of B it is F. So thermodynamically we can find out this formula, kids. Everyone. Yeah, thermodynamics is the most important thing in this world. Without thermodynamics, we cannot complete any chapter. If we want to get in-depth knowledge of any chapter, we have to remember, see kids, we have derived this formula. King Baba, Maruti tire. Maruti tire, 1000 Hanumanji. Wow. Shubha, Muthu Krishna, very good. Oh my God. Kashish, it's working. Kashish, do let me know it is working. Is this formula working? Are you able to find out that this formula is working properly, kids? Everyone, Vedha Janani, Joseph, Buddha Surya, everyone do let me know, is this formula working? Maruti tire, 1000 Hanumanji. It's working. It's easy now. Fantastic. Now see, kids. Here is one question. Just see to it and try to answer it. I have done a lot of homework for you just to save your time. So everyone's time is important, just to save your time. See, lot of homework I have done because this chapter holds a hell lot of weightage. Absolutely working. Thank you, kids. Thank you. Thank you. Likes are 117. I'm waiting so that it could reach 120. After this, only osmotic pressure is left. I will complete after this osmotic pressure. I will let you know. Nithya. Thank you, Nithya, for liking it. Now, see, kids, how to do it. How to do it. Molar depression constant. So just we have to apply delta TF is equal to KFM. Okay. Now, it's this much molar depression constant. So this is what? The value of Kf, 1.86 Kelvin kg per mole. So this value I will write over here. Let me write down 1.86. Am I right? Kelvin kg per mole. This much is molality of urea. No, this is not the molality of urea, or this is the Kelvin kg per mole, and this much mole per 100 gram of water. So molality will be 0.02 upon 100 into 1000, right kids? This much is okay. Now what they are asking, molar depression constant of water is this much area will produce depression and freezing point of. So how to solve it, kids? Now are you able to do it? Now see what is going to happen. This 100 I will remove by this. Now what I can do, this will become 0.2 and 0.186 into 0.02. What you are going to get, kids? How much you are going to get? 186. Double of 186 is how much? 1.86 multiplied by 0.02, or I can say 1.86. This gone with this, it's gone 0.2 multiplied by 0.2. So how much you are going to get, kids? 8 2s are 6 2s are 12, and 8 2s are 16, 17, 2 1s are 2, 3, and how many points? 1 2 3. So 0.372. This much answer I am getting C point. C is the answer. Everyone is getting 0.372 as the answer, kids. How is my maths, kids? I'm solving each and every question up to the last. Have you seen chemistry teachers solving question up to the last in your school or in your coaching? Oh, yeah, Basin sir, to Veera level. That's why our team is Veera level, kids. That's why our team is Veera level, kids. Done? Everyone done this? Now, see to it. Osmotic pressure. We are going to deal with osmotic pressure. Redo. Relative lowering in vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. So we are going to deal with, okay, osmotic pressure. Just try to find out osmotic pressure. For that, we have to understand osmosis. If we want to understand this osmotic pressure, we should know osmosis, kids. Do you know about osmosis? See, what is osmosis? Let me take one chamber. And let me separate it through semi-permeable membrane. This is semi-permeable membrane. Have you ever heard the name of semi-permeable membrane? What are the examples of semi-permeable membrane? They can ask you question, what are the examples of semi-permeable membrane? So these can be animal bladder, parchment paper, or parchment paper. Now see, kids, let me take this side. Let me take 1 molar glucose or 1 molar sucrose solution, and this side 5 molar sucrose solution. Both are sugar solution. So this side also water, that side also water. Both the side we are having water. Now kids, do let me know from which side to which side water will flow. Let me say this is side A, this is side A, and that is side B. From which side to which side water will flow? Because sugar cannot flow, that is the solute. Solute is not allowed. 5 to 1. Kashish is saying 5 to 1. Everyone else? Everyone else, kids? Now kids, everything where it is more, it flows to opposite side. Where water is more, this is more concentration. The one which is more concentrated means less solvent. More concentrated means less water, Less concentrated means more water. Less concentrated means more water, kids. Now, wherever water is present, more water is being the solvent, it will flow opposite side. It will flow towards opposite side. That means water will flow from this side to this side. This is the moment of the flow of water, kids. In this way, water will flow. Now, let me give you one more example. If you are able to understand, the solvent molecule moves from, let me write down the statement for it and then try to understand. I'm writing two statements and do let me know which one is correct. Everyone, it's your duty. I'm going to write two statements, statement number 1 and statement number 2, and you have to tell me which one is correct. First statement, during osmosis, solvent will flow from its higher concentration towards its lower concentration. One statement. Now statement number 2, kids. Statement number 2. During osmosis through semi-permeable membrane. One more point. It cannot move like this. Through semi-permeable membrane. SPM. Semi-permeable membrane. The second point I am going to write, kids. During osmosis, solvent moves from less concentrated solution towards more concentrated solution. Through semi-permeable membrane. Which statement is true about osmosis? Do let me know. Which statement is true? Priyanka is saying first, Vedha Janani is saying second. Kids, do let me know which statement is correct for osmosis. Kashish is saying both. Nithya is saying 2 is correct. Kids, just see and watch it and then try to answer. This is less concentrated solution. This is less concentrated solution. Try to understand, kids. Less concentrated solution, right? Or I can say having more concentration of water. Even I can say having more concentration of water. Solution less concentrated, that means having more concentration of water both mean same. Both point means same. Am I right? Less concentrated solution means less solvent, means more concentration of water, and the water is moving from this side to that side. Both the statements are correct, absolutely correct. Now see, this is indicating during osmosis solvent will flow from its higher concentration. Its higher concentration is indicating what? It stands for what? In English, this it stands for water only. Its higher concentration towards its lower concentration. Now, during osmosis, solvent moves from less concentrated solution. So, both the points are absolutely correct, kids. Are you getting my point? Now, let me tell you the physical significance of this osmosis. See, kids. Physically, how will you see the osmosis? Just see to it. Everyone, focus. If suppose my mother made one, what to say, in the milk you are going to add fruits. What is that? Custard. What do you call it? When you add to the milk the fruits, the raisins, what do you call it? What's the name? What do you call it? Custard. Okay. So you have taken milk for making that custard. We are going to prepare custard, and we added sugar to it. Sugar we have added, and we have added raisin, kishmish, you know, raisin. Now kids, do let me know, this is the shape of raisin. Before adding, it's like this. It will swell up or it will shrink. This raisin, question is, this raisin will swell up or will contract? First option, swell up. B option, contract. C option, both may take place. This is in our daily day-to-day life we can observe. Now, what's your answer, kids? Have you ever made these things? The kulfi, the raisin, the custard. Now, kids, let me tell you, the correct answer is both may take place. Should I explain? Should I explain? Both may take place. Should I explain, kids? Should I explain? Should I explain, kids? Should I explain? Should I explain, kids? See, kids. This is one custard. This is second custard. Now see, if this is having milk, sugar, and due to sugar, and first of all, let me tell you, this is your raisin, and let us suppose the molarity of raisin is 1, or let us take 2. Molarity of raisin is 2. This much is sweet in taste. Now, this sugar I have added to the milk. There is milk and sugar, and its concentration, let us suppose the molarity is 5. And here, milk, sugar, somebody has added less sugar, very, very less sugar, less amount of sugar, more of milk, more milk, and its concentration, molarity is just suppose 1. Now both have added this resin. Now see this resin in this and this resin in that. The wall of resin is semi-permeable membrane. Now see kids, this is highly concentrated, this is less concentrated. Once it is going to this is having more water, it will lose water and the resin will shrink over here. It will shrink over here, shrink. Here it is going to shrink. Now kids, this is 1 molar, this is 2 molar. This is having more water. The water will, more water, it is having more water. So water will get entered inside it and it will swell up. The resin will swell up, Kids, are you getting my point? So this solution is known as hypertonic solution. That's why it is more concentrated. This is known as hypertonic solution. That is less concentrated. The less concentrated is known as hypotonic solution. Hypotonic. And kids, if somebody is having this one, the sugar and milk plus sugar, if they are making concentration to be only 2, we will say this is isotonic solution. Now the resin will not have anything because both are being equally concentrated. So in this solution, if the resin is going, it will remain unchanged. Resin will remain unchanged, Kids, are you getting my point, everyone? Now kids, why this knowledge is important and how it is going to help the doctors. You must have seen doctors when they are going to give antibiotic, they take some salt solution and they add to it. They are not directly going to give medicine. They will take some salt solution and they will add it to maintain the pH. If by chance, whatever the medicine doctor is injecting inside the, whatever the intravenous or whatever the thing, if the concentration of medicine is not matching with this blood concentration level, so either it will swell up or the cells will get shrink. The best doctor is the one who is maintaining the equal concentration, the isotonic solution. So neither the cells will get swell up nor they will get shrink. Otherwise the cells will get burst because the blood circulation will not be proper. Kids, are you getting my point? Everyone, are you able to understand? Yeah, this is in bio also, everywhere the same concept. Are you liking my teaching, kids? I'm telling you each and everything in detail, each and everything, kids. If yes, everyone smash the like buttons. Now, kids, see to it. How the formula, we are going to derive the formula, see to it, kids. The formula. As we know that PV is equal to nRT. PV is equal to nRT. This we know. Oh, first let me tell you what is osmotic pressure. I'm explaining the formula. What is osmotic pressure? Till now I have told you only about the osmosis. See, kids, everyone see to it. What is osmotic pressure? So see, this is the solution. And let me divide it by semi-permeable membrane. This is being semi-permeable membrane, SPM, semi-permeable membrane. Now if I say this side I am having sugar solution of, let me don't take sugar solution, let me take normal water, and that side I am having saline water, you know, sea water, saline water. So kids, which is more concentrated? Could you please help me? This is sea water. Saline water means sea water. Sea water is having salt in it. Then definitely it means this is being more concentrated. This is being more concentrated. More concentrated solution. This is being normal water. So this is diluted one only. Diluted. Now, what do you think? From which side to which side water is going to flow? Definitely water will flow from this side to this side. Am I right, kids? Kids, let me know, am I right? Am I right, kids? Am I right, kids? Do let me know. Everyone, do let me know, am I right? That this is more diluted, so definitely the water is going to flow from this side to this side. But if we don't want that water should flow from this side to that side, I want that water should flow from this side to this side. What I'm supposed to do? What I'm supposed to do? I just want to reverse it. I want to prepare salt from the seawater. I will put force from this side. Now I have to supply energy because I'm doing something against the feasible thing that was taking place by its own. This was feasible process. This was feasible process, a spontaneous process. Kids, are you able to understand? This was spontaneous process was taking place by its own. Spontaneous process. This was spontaneous process. But we want to do something against the spontaneity, then we have to apply this is reverse osmosis. Yeah, we have to supply some extra force pressure. So the minimum pressure, you know the word minimum? Do you know the word minimum? What is the meaning of minimum, kids? Do you know the meaning of word minimum? Suppose if the pizza is of rupees 200, so how much rupees do you need to buy to purchase that pizza? If the price of pizza is 200 rupees, how much money you need to purchase that pizza? Buddha Surya, yes, sure. 200, no, wrong answer. At least 200. If your mother is giving you 1000 rupees, then also you can purchase that pizza, buy that pizza. If your mother is giving you 1 lakh rupees, then also you can have that pizza. At least you should have 200 rupees, at least. That is the minimum money it's required to buy the pizza. More than 200 or more than 200, it will work. Am I right, kids? Am I making any sense? Everyone, are you able to understand what I'm telling you? At least that minimum amount you should have to buy that pizza, that is required now. So the minimum amount of pressure applied to more concentrated side from more concentrated side from more concentrated solution side to just stop osmosis, is known as osmotic pressure. If you're applying more than this pressure, if even a little amount of pressure is applied more than osmotic pressure, then reverse osmosis will take place. So this is osmotic pressure, and let me tell you, this will have PV is equal to nRT, we know that. So I would like to say P is equal to N by V RT, and N by V is concentration. So we will say pi is equal to CRT. CRT, this pi is being osmotic pressure. This is being osmotic pressure. And in this way only salt is prepared from the seawater. This is the way how the salt is being prepared from the seawater. Now see kids, if I say I'm provided with isotonic solution, if anyone is saying that we are provided with isotonic solution kids, if we are provided with isotonic solution kids, if we are provided with, this is Marti Nandan, Hanumanji, if we are provided with isotonic solution kits, what is the meaning of isotonic solution? Isotonic solution means that concentration is same. When the concentration is same, I can say pi 1 is equal to pi 2. I can say C1 RT, C2 RT. So RT is constant. These two terms are being constant, isn't it, kids? So what I can say, C1 is equal to C2. This formula is valid only for isotonic solution. You cannot apply everywhere. This is valid for isotonic solution, and number of questions you can do with the help of this. Baba, we can say that reverse osmosis and osmotic pressure is same. Only a slight difference is there. Yeah, osmotic pressure is same. That reverse osmosis, in reverse osmosis you can apply whatever the pressure you want to apply. Yes, just to start reverse osmosis, that is osmotic pressure. Just to start. See, if you are having pizza of 200 rupees, pizza of 350, pizza of 1000 rupees, just to buy the pizza, how much rupees you need? At least 200. If you are having 350, you can buy better pizza, 1000 rupees, more better pizza. But just to buy pizza, how much money you should have? That is the threshold value, at least 200 rupees. Now, Raoult's law, I will let you know Buddha Surya in detail in the next lecture. Raoult's law, azeotropic solution, ideal, non-ideal solution, the tricks, each and everything, Henry's law. But right now, focus over here, and I'm going to tell you, kids, osmotic pressure. I've told you, so always remember the formula whenever somebody is asking what is osmotic pressure, what is the formula for osmotic pressure. Now, kids, on the basis of osmotic pressure, I'm going to give you one question. You have to answer it. Will you please let me know? Are you going to solve it? Question is, which will have maximum osmotic pressure? Options are option A, 0.1 molar NaCl, option B, 0.1 molar glucose, C, 0.1 molar Al2SO4 whole thrice, D, all will have equal. Everyone, do let me know what's your answer. I'm waiting for your answer. Only 5 minutes more, then the class will get over, kids. Next session will be on today's Friday, Monday at 6 p.m. Next session will be on Monday at 6 p.m. kids. Hit the like button. It's only 122. Oh my God. Correct answer, kids. Rocking. You are rocking, kids. This, because its particles are more. More particles. More colligative property. more osmotic pressure. Now see kids, everyone see to it. Here is one question. See, here is one question. Try to do it. Hit the like buttons. Smash the like button kids. I want to see 130 likes to get reach up to 130 kids. Session is going to get ended just in 5 minutes. And the next session based on this Henry's law, Rod's and Dalton's law, their relation, tricks for ideal, non-ideal, Venn top factor means the backbone of this chapter. I will let you know on Monday. C. Swatiraj C. Everyone is saying C. So definitely your C answer is correct because vapor pressure is not a colligative property. Boiling point is not a colligative property. These two things are not colligative properties. These are not colligative property. But yes, osmotic pressure definitely it is being your colligative properties. So this is the correct answer. Kids, everyone is able to understand. Is everyone getting it, kids? Is everyone able to understand, kids? Do let me know. Now kids, I'm going to frame out one really fantastic question. Everyone is ready. Is everyone going to do that question, kids? See, question is, which solution will have maximum osmotic pressure? Maximum osmotic pressure. Now see, A option is 1 gram 1 gram urea in 1000 ml H2O. Option B is 1 gram glucose in 1 liter water. Option C, 1 gram sucrose in 500 ml, not 500, in 2 liter water. Now D, 1 molar K4 FeCN whole 6. What's your answer? Everyone do let me know what's your answer. Oh my god, you are fast. Your answers are really very awesome. D is the correct answer because this is highly concentrated. Highly concentrated. Now kids, weight has no meaning. Remember that weight has no meaning. Always convert it into concentration. 1 means 1 divided by 60 into 1 liter. This is going to be the 1 upon 60 molarity. Here 1 divided by glucose is how much? 180, and this is 1 divided by, my god, 1 divided by how much? 342 into 2. So this is 1 molar. This is highly concentrated, and that's why this is the correct answer. Kids, everyone able to understand? Is everyone able to understand, kids? Yeah, Buddha Surya, thank you for noticing. really now only 2-3 minutes are left. The session is going to get ended because for today's task I have completed. Now only 1-2 questions I am going to give you. Just focus over here, everyone. Okay. Now another question. Let me check whether I have started in the morning till now. It is there in your brain. First flask, second flask, and the third flask. And just see one more flask. This is fourth flask. And let me change the color of this flask. This is the fourth flask. Fourth flask we are having. And let me tell you that if I am having some solution in this, let us suppose I'm having H2SO4 solution in this H2SO4 solution marked as normality is equal to 2, volume is 34.4 liters. This is flask number 2. It is having just what? It is having 20 ml of water. 20 ml of water, and this is having 5 ml of water, and this is not having anything. So kids, let me tell you, let me write down. This is having 20 ml of pure water, and this is having just 10 ml of pure water. This is empty vessel, empty. Right now it is empty. What I have done kids, I have taken 20 ml of H2SO4 solution and I added to this 20 ml of water, 20 ml of H2SO4. After mixing, it has become 40 ml. Definitely it will become 40 ml. Once mixing, I have taken 10 ml of H2SO4 solution and I added to this 10 and 10, 20. After mixing, what I did, I have taken 3.5 ml of H2SO4 solution to this and I added to this. Now you tell me what is the normality of this solution. Let me check it out. How much you got it? Thank you, JDSS. Thank you. All these comments you have to write in the right now chat section is going on. Once the video is over, once the video is getting over, everyone is supposed to write these really loving comments in the chat section. I would like to see, and don't write down the answer right now. I would like to see this answer as the homework. Vishal, thank you. Everyone, I want to see this answer in the comment section. Kids, don't write down the answer right now. I want to see the answer of this question in the comment section. This is your homework for today. I'm giving you homework and I want to see everyone's answer to be correct. This is your homework for today, kids. And I hope that you will definitely find out the answer in the milkman style or whatever the style you are going to opt for. You have to find out the answer, kids. Is everyone ready? That say yes, sir. Just after this amazing session, once it is getting ended, we are going to write down in the comment section how much you liked it. As I've told you, this was my first lecture at this platform for the physical chemistry, and that you have to indicate in the comment section, and along with the answer, the comment should be there. Make me promise, just say yes, sir. Just after the video, once it is getting over, we are going to comment over there, because kids, my water has got ended. No more water is there in the water bottle, and for constantly 6, not 6, it's 4 hours, 4 hours continuous teaching from my side, and you're studying for the 4 hours. It really needs lot of patience. Thank you, kids. So, God bless you, kids. Love you, kids. Keep sharing. Try to share it to maximum students. And if you want to take admission for NEET batch, that is Avengers 2.0, really awesome batch. If you want to take admission over there, you can enroll over there. Only few seats have been left. And kids, you can watch that lecture for the really before day to day up to Thursday. You must have seen that was our special, yes, batch or special week for special free classes. I've given number of things based on NCERT. Those students, those who have seen, second session will be on Monday 6 p.m. Next session will be on Monday 6 p.m. Next session will be, kids, let me write down. Next session is on Monday 6 p.m. Next session Monday 6 p.m. Now kids, what I was telling you, the NCERT based mind-blowing sessions I have taken on the plus classes. They are available free of cost. You can see all those classes, kids. Nitya is really, kids, I will pray to Almighty God. God bless you with all happiness and prosperity, kids. But you have to do one thing. If you're liking all these things, the videos, the teaching style, at least share to 2 students, 2 of your friends or relatives or school mate students, because sharing is caring. And if you are sharing to others, Almighty God is going to help you a lot. And I'm new for the YouTube, kids. You have to support me. I need your support, kids. Bye, kids. God bless you. Love you. Bye to all of you, kids. Bye to all of you.